Hey, what's up, everyone? How are we doing? Just day of exam. How's everyone doing? No one's in the chat yet, I don't think. I haven't sent announcements yet. Let me see. We're talking on Discord, I think. Yeah. Here we go. Awesome. Reading everything. Yeah. Totally agree. Awesome. Pick up my pings. Yeah. I think we're talking on, but if anyone joins in, I think we're broadcasting live, right? I totally agree with the person I'm talking to on the Discord right now. Join up on the Discord. Let's see. Here we go. Let me put a thing out. I think everyone's studying away. If you're in the chat, feel free to say, hey, Mubot will see you. Oh, is it saying, am I streaming? I am streaming. Woohoo! We are streaming. So there we go. We are streaming. No one's said anything in the chat yet. I think we've all had a long semester. I really want to create something that carries over between classes. I am live on YouTube now. If you want to join in the chat. There we go. Let me say everybody. Everyone. We'll ping everyone. Send now. I've just been pinging everyone on the server lately. No, but we're talking, let them, hey, Demetrius, what's up? Good to see you here. I was looking over at the Discord, and Demetrius, if you have questions, let me know. Exam's going pretty well right now, but no, Discord's going great, and so Demetrius, first here, you get 100 points. Get some quick points right out there. I think Mubot, are you not giving out points today? What you doing, man? You okay, Mubot? You feeling all right, buddy? I'll click his buttons again. Sometimes he acts a little bit weird. Sometimes when I connect things in, they don't instantly connect. So like I've got Mubot here in the background, and I'm going to reset Mubot. We'll see if he wakes up properly this time. So we're going to reset Mubot here, just reset the bot. But no, Demetrius, thank you so much. Demetrius, excellent job this semester. Really proud of everybody. We can cover a topic if people want. Hey, what's up, Matthew? No, I totally agree with what you're saying. Like, I figured if you want to just say hi here, and Sherry and Trevor, great to see you. Mubot's waking back up. Let's see if we can give out those points. Mubot's being weird today. Let me type the... Oh, it's not sending the... Let me try the manual sending of points. I might need to reset the computer. Okay, it looks like... Yeah, Mubot can see that. Is calculating T different from TDF? So what is the... That's a good question right there. And gonna... Oh, Trevor, swing by anytime. Hop into this, join into this anytime. Mubot's not... What's up, Brandon? Great to see you here. Let's talk about T versus TDF. Good questions right there. What is T? What is TDF? And everyone is always welcome to swing back high. What is T and what is TDF? Okay, let's go check those out. Yeah, exactly. And tell them to join up, especially if they're taking 320 or something. What I really like about, and so this is to like Matthew's thing, is it's become like standard practice. I totally agree that at the start of semester, like who's making the GroupMe? I even see that in our chats, like who's making the GroupMe? GroupMe's all right, nothing against it, but it's Kiana. So good to see you, Kiana, from our senior level classes. Good to see you here, Mary. Mubot should be sending out points. He should be. It's become standard practice. Say like, what is the GroupMe? Where's the GroupMe? You know, like what's going on with the GroupMe? But what I'd love is if we had like everyone's like, oh, just join the server, and then when you join 320, you can see every class. Like the goal of Stat Nation is you have a consistent group of people you can meet and talk between throughout all your classes, and you're not just in like one GroupMe. If you take 201, 320, 474, 475, 471, all these classes, you can just hop over to another class and you can meet people and grow relationships more than I was in one GroupMe with one class. So that's kind of, as Matthew says right there, the exact like something that carries over, and you don't have to worry about like where's the GroupMe. You're just like, oh well, we got this server that you just joined. It's not a thing for yeah, Mary, I hope you like it. So it takes a little figuring out. I do agree with that because a lot of people understand GroupMe. GroupMe is just very simple. It's like go on your phone, GroupMe, boom. So that's the ease of it. But then Discord has a lot of bonuses with it. I'm so close, Trevor. You'll get there. Where's Trevor at? Trevor, Trevor's going to get to that super duper bonus. All right, let's talk about what is the T and the TDF. Okay. So really, kind of let's differentiate between two formulas right here. And I think So there's like these spam bots lately. Sure. There we go. Look at that. That's where we moderate. I think it's spam bots. Spam bots go away. So we have here y bar plus or minus. What am I writing right here? Who knows what this formula is? So this is actually has a degrees of freedom n minus 1. So what is this right here? What is this? Who can explain what this is? I'll talk about what the values are, and if you can tell me what this is used for and what it is, that's a good understanding. We're going for a little deeper understanding here, but like, what is this formula? It's not going to be a test question like that, but we should know this is the sample mean, this is the sample standard deviation, this is the sample size, and this is the t used to calculate based on the degrees of freedom. Mary, we could do that next. It's categorical versus quantitative. We can do that next. You got it. Categorical versus quantitative, the variable type. So what is this formula used for? What's the point of this formula? Like, we're going to use this to calculate a confidence interval for the what? You can tell it's a confidence interval because it's got a plus or minus on it, which means this is the margin of error. And then this first part right here is our estimate. And so the estimate is going to be what we're talking about. Confidence interval for a one sample t exactly, which is a confidence interval for the mean. To Mary's question, would we use success failure or nearly normal on this? So this is a good way to bring in Mary's question. Would we use, and then we'll say why, would we use success failure or nearly normal? So Sherry's right. This is for the mean, which kind of gives us an idea of what we would use right here. We'd use nearly normal because it's quantitative. So the categorical one where we would use success failure, we'll go back to Dimitri's questions here in a second, would be the p hat plus or minus the z star. And I should put stars on these, meaning we get to pick them. And then p hat q hat over n square root. And this follows the same practice right here of this being the margin of error. I'm not blocking it good. That's the margin of error. And this right here is the estimate, which is what we're making the interval for. We're making the interval for the true proportion from an estimate of the sample proportion. And p hat is the sample proportion, which estimates the true proportion. And that's where we do the interpretation. True, great to see you here. So this one would use success failure, Mary, because it's categorical. The other one uses nearly normal because it is quantitative. And so good stuff right there. Great question, Mary. Let's throw out little points here, little bits. So you know what I'm going to do? I'm going to do something real quick. So Trevor's trying to make it to the secret level. Trevor, so this is just secret level, which is very, very tiny. It's very, very tiny. Don't worry, it's so tiny, but Trevor is so close. Oh, Trevor, you actually have 2 accounts. No, I'm not even joking. So basically, this is me just almost merging your accounts. Trevor, you should recheck your points here. Let me go away from that screen. But Trevor, you should recheck your points there, Trevor. Can we go over tests? Yeah, we'll go over test statistics here in a moment too. You bet. And so to Dimitri's question, that's not really. It looked like I was selecting eraser right there. So to Dimitri's question, and you had 2 accounts, so I kind of merged them actually. It was the other account had very low, like 2,000 points, basically enough. To Dimitri's question, and then Mubot will update the level here soon. So sorry, Mubot's a little behind on that. Dimitri's is saying, what's the difference between the T and the TDF? Well, the DF of it just means the degrees of freedom. So the real difference people usually get tripped up on is the difference when we talk about this right here, where we do something like T, and then this one would not have a star. It is still n-1 degrees of freedom for the one sample T. And this is when we are doing a what? This formula right here is when we are doing, it's a 4-letter word for what you'll be doing later today. You're welcome, Trevor. Merry Christmas, happy holidays, whatever you celebrate. Have a great holiday season. I'm happy to celebrate the holidays. My family has celebrated Christmas. That's a little bit ingrained in my head, but happy to whatever anyone is celebrating or not celebrating. Happy time off from school. What is this thing right here? What is this thing? It has a lot of the same components, but the big thing to note, probably the most important thing for us to see is this. That's going to be the real thing going on. Demetrius has got to that rockstar level. Good job, Demetrius. So this thing right here is a what? Which that's super important. A lot of people forget what that is in notation. Like, what is this? This is going to do a what? The other one, this one over here, is the interval. That creates an interval, and it's mu naught. Great job, Demetrius. And mu naught is when we have a hypothesis value, mean hypothesis testing, exactly, because we have a hypothesized value and we're going to test it. Now, the key difference right here, I'm just going to make it as big as possible or highlight it right here, is this star. This star right here looks all crazy right there. That's what stars look like if you expand on them. It's hypothesis. Great job, Demetrius. So the star means what for the t? That looks ridiculous. The star, let's focus in on just our attention on that. Why, oh why, do we usually put a star? We like to put that star right here to differentiate these two t's. What is that star going to tell us between these two t's right here, which is kind of very important. A lot of people think, well, we could then solve for the t and know the t, like this solves for a t, but they're not the same. They use the same ideas, but do different things. The star over there means when you make an interval, you what the t based on your level of confidence. So the reason the t for an interval has a star, hello, Ditto, great to see you. Aubrey is right there. We pick the t based on our level of confidence. Does that make sense? We pick a t based on our level of confidence. So if you're 95% confident, and this is like some of the test questions you can kind of solve a little bit by being like, well, it's a 95% confidence interval, so the t is probably going to be close to 2. Kind of change it. It's decided on by the level of confidence. So we don't solve for t in a confidence interval. In a confidence interval, t is associated with the level of confidence. So these are just, it's the same kind of distribution it comes from, but it's not the same value. In the test, you find the standardized difference. So here's the difference up top, and then you figure out how far it is away in standardized units, standard errors on the bottom. So this right here is a t that you solve for, and this will have an answer dependent on the null hypothesis. This one is a t you pick based on your level of confidence. Corral, great question right there. I think we got one more before that, and we'll do that one next. But does this make sense right here that these are two different t's? And the df part of the t is just the associated with the degrees of freedom to kind of Demetrius' question. So if we ever add like a df to it, a lot of times this could be called TDF, but the degrees of freedom would be n-1. It's just a subscript telling you which t you are using. We don't usually call this TDF. We usually call it t with n-1 degrees of freedom. It could be called TDF because the df right there would be n-1. Now, this goes out to Demetrius and everyone else. I'm going to have to get the answer to this. So I'm literally going to find this 2 sample t degrees of freedom formula. So if we were to do the following, Demetrius, such a good question right here. The reason we call it TDF is because we have right here, whoops, no. Y bar 1 minus Y bar 2 over S1 squared plus S2 squared over N1 over N2 square root. Okay. So that's the formula for that one, but we could call it, give me a second. Copy image. Let's see if this works properly. I was afraid when copying images, something crazy is going to happen. There it is. Okay, so 2 seconds. So Demetrius, we call this one TDF, but if we really wanted, we could call it T. Okay, and then there's that. So Demetrius, if we wanted to go crazy right here, wrap text. Yeah, there we go. All right. So the reason we call it TDF is because if we really wanted to be particular, we could call it T and then add the subscript right here of there's, does that make sense, Demetrius? So this is a pretty complex one. If you wanted to call it like a T subscript degrees, so the degrees of freedom is just an abbreviation for the formula we use. The reason we write n-1 on the previous one is because that's the formula, but the previous one could just be called, for the one sample T, TDF. So on the T with n-1 degrees of freedom, we're just writing n-1 because it's the degrees of freedom formula. But both of these, if you wanted, could be called, they could just, for brevity, it's just so easy to write n-1. They could both be called TDF, and that's a D. My handwriting there, that looks more like a D. So we call it TDF, but you could call the bottom one n-1, and the top one would need the complicated formula. Yeah, and then Trevor, there's so many great questions. I think what was the first, let me write down the questions right here so we don't forget. First up, I want to make some stuff where we can see the questions on the sidebar. Like, so the first, let's write these down. We have type 1 and type 2 error. That's second. Someone said interpretations. And then conditions. And then there was one earlier on that I remember, but I'm writing them down now so I don't forget. I told them we would talk about it. Test statistics. I think Tara said test statistics. Tara. And hello to Tara's cat and everyone's dogs out there. The one class got 2 points. The other class got 1 point. I can check it out. Test statistics. But one class got 2 points. The other class got 1 point. So 2 points and 1 point associated with that. Let me go grab those. T on voice, and I'll show that 2 seconds right, and then I'll do the next question while we do this. Over here, 2 points and 1 point. Good job. Good. I'm proud we got some points. I wanted us to get all the points. It's very hard to get to that top level. A few classes do get to the top level, but I'm proud we got some points. That's what we want. At least some points. It all depends. At least it's something. I do agree. Let's head back here. We'll check it out real quick. So this is the morning class. The 004 is the morning. I'm 99% certain on that. The 004 is the morning, and there's the afternoon. And it is possible to get up to these higher percentages. It might be tougher for bigger classes, but 90% was the goal and so some of the other classes got 90%. And thank you so much for everybody. I really appreciate it. I want every student to know that I'm there for them, and it's been busy. Let's see who's been busy. But no, I appreciate it. Great responses. We got some points, and that's what's awesome. I like it. And this really helps me. Really helps me know what people are thinking, and I read every review. I'm not the only one who reads every review. My department reads my reviews too. My Haslam College of Business reads my reviews. Maybe today is test statistics. Let's talk about some test statistics. So when it comes to test statistics, there is multiple choice. There is free response. True, false, multiple choice. Very similar to test 2, the scary one. With multiple choice, free response, numeric entry, all those good things right there. So test statistics, can anyone name some test statistics? Can you name some test statistics right now? Not that. Can you name... I can think of 3 you should know. Not a Peppermint Patty, good to see you here. Can you name 3 test statistics? Test statistic, what are we talking about? Test statistic, think of standardized differences used to perform statistical tests. The value we solve for and then use to find p-values. Okay. Who knows? Some ideas out there in the chat. So if we say test statistic, what are we talking about? Piano chords right there. C. Oh, is that not C? C major. Z. Great job. Let's throw some big points. Great job, Josie. Z is one of those. Excellent work, Josie, right there. Chi squared. Do we have the chi squared symbol? Chi squared is one of another one. Where's my chi squared? Can I search it? I don't know if I'll ever find the chi squared. I wish I could just search it. Sure. Chi squared. Or you could... Chi is just like an X, basically. So it is a little tail at the end. It looks prettier. And then I think people are... Go away. People are saying the T statistic. Yep. T. There's actually more. There's F. There's W. There's... F is the F distribution. W is the Weibold. Should know more than that off the top of my head. Can't think of them today. We're not going to talk about the F. We're not going to talk about the W. The F is a very big distribution based on the ratio of 2 chi-squareds. It's based on chi-squared. I guess, yeah, there's a bunch more. W is the Shapiro-Wilk used for test for normalities, which we have talked about in this class. But all these things do is there's some standardized metric. If I tell you my test score was a z-score of 3, or you tell me your test score is a z-score of 3, how would you feel? Who would be happy, yes or no, in the class right now if your test score was a z-score of 3? Would you be happy? I didn't tell you you're great. I just said it's a z-score of 3. Would you be happy? This is a good way to know your statistical knowledge is there. What would you know? You would know something if I said it's a z-score of 3, and would you be happy? So what it would be, what you would know, yeah, I'd agree with Corlin right there. I'd be very happy. And why? What have I told you by saying your test score is a z-score of 3? I've told you what? It's a standardized metric. What we mean by that is, you know in this instance what? You know what about your test score? It means you scored up here, and your test score is what? Even more than that, you're better than 99.85%. Corlin, great answer right there with 1 small point to say about it. You are 3 standard deviations above average. Exactly. You're at the top of the distribution. So, and then above average. You have 3 standard deviations above average. So this is what a standardized metric means. I didn't tell you you're great. I said, oh, you got a z-score of 3. And you're like, yes, at the top of the distribution. So you would know where you're at. And Rock knows
it doesn't matter.
It's standardized. So it doesn't matter what the average is or anything like that. You're at the top of the class. So we don't even need to say what the metrics are. So chi-squared is the same thing no matter the metric. When you say like the chi-squared is this, it's a standardized metric. That's what a test statistic is. It's a standardized way of looking at something for which then we can derive the what. What do we use test statistics for? We use a test statistic when doing a statistical test to then derive the what. So from a test statistic, we will use the test statistic. Like if we are doing a test right here, which would have to have a greater than alternative, we would then use it. P-score, p-value. Great job, Carolyn, right there. P-value. Yeah, you got it. You got it. Yeah. No, you got this. So p-value. So the p-value tells us the probability of this. And this is a very unlikely result. We would expect students to score kind of closer by random chance. If you draw a random student out of the class, and maybe they've studied or they haven't studied, we'd expect most students to score within kind of the bounds of normality, and most students' scores would be close to the what? Like a typical student, that's kind of the answer, a typical student would be close to the what? Oh, we're going to make you feel all minty today. You got this. You got this, Peppermint Patty. You got it. Don't worry. Don't worry. The average right now, if the grading is fine, is towards a C. So realize there's 16 extra points. People are making A's. I think one person even made 100 on the exam. There's 100 out there. There's A's out there. There are lower grades. I think the lowest I've seen so far is in the 50s. If they get the lower grades, the test has a range. I'll give you some confidence. But that's what test statistics are. Let me just give you a little confidence right now. It's not an easy test. It's not an easy test. There's 16 interpretation points. 16 interpretation points. So let's go a little test confidence right here. So, you won't have to. We'd do it like where you have to solve it via the less than, greater than, or not equal to Vincent. Good question, Vincent. We won't have you, anything we've done in class where we can solve without the applet is what we're doing, where we're like the less than. So check this out, Vincent. You ready? If the less than p-value is 20%, what is the greater than p-value? That is a very fair question to ask on the test. If the less than p-value is 20%, like for the less than test, what is the greater than p-value going to be equal to? That's a very fair question. So you'd be like, we can get this. We got this. Boom, Vincent, you know it. Because the less than and the greater than add up to 1. So what would the does not equal to be? And those are interpretation. There's 16 points that are not graded yet. They're not extra, but they're just not graded when you turn it in. So what would the does not equals? If the less than is 20%, the does not equals would be equal to what? If the less than is 20%, the does not equals would be equal to what? So that one we can solve for too. 40%. Vincent, you got this. You know that the does not equals is double the smallest. So sometimes we hide numbers in output and ask you to solve for them. And they just have to know how to read the output which we've done practice on. So, well, remember, so we double the smallest, Josie. Good job right there. We're going to double the smallest. You got this. And so much positivity in the chat. So I want to say this, though. We're seeing that the average right now is towards a C. If you see your grade is in the 60s when you take the exam, you're towards the average. Because remember, there's extra points. If you see you got a 62, you're like, maybe I did about average. Not the end of the world. If you see you got in this, let's say you finished the exam and it says 80. We're going to the main screen for this. If you take the exam and it says you got an 80, how are you going to feel afterwards? I want to know this because I want to make sure everyone knows this. I don't want people to get overly anxious when they see their grade. If you see an 80 and you finish taking the exam, how are you going to feel? Amazing. Great. You're like, yes! You probably got an A as long as you did well in those interpretations. We'll talk about those here in a little bit. No, but if you see an 80, that means there's 16 points that are not graded because you could have as much as 16 points extra on top of this. What is the maximum grade you could possibly see when you take the exam? Just think over here. What is the maximum grade you could possibly see when taking the exam? A dream. 84. 84 is the maximum grade you could see. Well, I think I know what Sydney's saying right there. When you finish the exam, the maximum grade you could possibly see is an 84. That is the maximum grade you can see. So don't be like, man, I studied so hard, I got an 84. Be like, yes, everything right that's been graded. Be excited about it. Probably what a lot of people are going to see, I would guess, from what I've been seeing from the data so far, but we're seeing early takers right now. People have been taking it earlier. We're seeing a lot of around, I think, 63. Let me double think. Yeah, because I estimated 10 points. Yeah, so it's around 63 because I'm remembering all the math I did. If you see around 63, if you know the interpretations, which we'll talk about here in a little bit, and people don't know around the interpretations, pretty good, but follow the structure. I might even bring up our structures that we did. Follow the structures that we have for interpretations. You could, your highest grade, if you make a 63, could be a what? And I'd guess you probably made around a C. Probably. It's a good guess. You made between a D and a high C. Somewhere in there. Like, so you could make as high as a 79, which is not a bad grade on test 3. And 79, if that's the average, I'll be very happy if we have a high 70 average. Probably around a 75 average. 79 exactly. So the only areas you really want to be worried about, like if your grade's borderline, is when you see things like a 40, which there's been a few people making that low, and there probably will be more. And it's okay. Nothing in the world. But the interpretations right there are going to be the plus 16 points. But my guess, this is what I'm seeing as an average right now. And a C average is kind of what we generally see on tests. We don't see, no matter what any random website might say, we don't have an average of a 40 on our tests. Not better. And I don't teach Bio 1010. Anyways. I think we're going to do that here in a second, Mary Beth. I don't teach Bio 1010. Apparently I do, apparently. Yeah, am I okay? Apparently I teach Bio 1010 and my classes have an average of 40 on exams. Not better. Let's go over to type 1, type 2 error. We'll do interpretations here in a moment. We're just going to... There might be. You never know. We talk as instructors and we'll try to be as fair as possible. We won't have a 40 average. Just writing a website trying to get them to fix something that shouldn't be there because obviously I don't teach Bio 1010 and... Anyways. It's crazy. Okay, here we go. Type 1, type 2 error. I think it was in the low 70s. I'm hoping this one's upper 70s. I think it was low 70s, Chloe. Okay, what is our number one way for remembering type 1, type 2 error? Who can do this right here? Yeah, Matthew's got it right. We're going to cover some keywording here in a moment. Matthew, great job. Matthew, some points in the chat. I'm going to stay positive. I kept telling myself I'm not going to get negative about those things. Whatever. What is our way of remembering type 1, type 2 error right here? We got a really quick and easy way, and we want to memorize it that we can just literally say it off the top of our heads where we're like, boom, 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 boom. Like you can memorize this, get it down. Who knows it right here? If you've been following along, watching our videos, you probably know the trick for type 1 error and the trick for type 2 error. Yep. Let's review it again right here because someone's probably watching this right now and wondering what the heck is going on. So in a type 1, does everyone see the 1 right here? In a type 1, the null is what? Everyone put in the chat, what letter are we making right here? Because we talk about the null hypothesis and what we do with it. So all of our talks on this are what the null is and what we're talking about. In a type 1, the null is true. Great job, everyone putting that in the chat. And if the null is true, what would be an error? If the null is true, then it would be an error to do what? Some of these are just kind of knowledge of, do you know what a type 1 error is? Like, I think we have some questions sometimes that can appear on the test. If the null is true, it'd be an error to reject it. Like, when you think about this, we did a really good example. I'm going to steal it from our fire example. When your smoke alarm So this is a previous example we did a few days ago. Your smoke alarm would look for evidence of what, which makes it the alternative. I've got it written on the screen if you want. I'm going to try to like do as many topics as we can before I burn out. And I need to go answer emails and discords. Your smoke alarm is going to look for evidence of a fire, right? So the smoke alarm has the null hypothesis, there is no fire. For your smoke alarm to go off, it needs evidence of a fire. Does that make sense? For your smoke alarm to go off, it needs evidence of a fire. The fire is the evidence-based claim. It's not looking around at all points to see if there's no fire. It's monitoring the environment to see if there's evidence of a fire, making it the alternative. It would then reject the null if it thinks there's evidence of a fire. So the big question becomes, and be very careful and very slow, what is a type 1 error? We covered this previously, but it was a really good example. What is a type 1 error? I think, Carolyn, you are correct. Carolyn is correct. No, Carolyn, you are correct. And just do it nice and slowly right here. We'll go with the type 1 first, though. There is no fire, but the alarm goes off. I think Finch has just explained it perfectly right there. In a type 1, the null is true. And just look, this is the way to do it. You look at this null hypothesis and you say, this is true. So just tell me, just start with this. What is true? So what is true right now? Just look at the null and be like, that is true. Just tell me, like, this is true. This is a true statement. So what is, just tell me, since the null is true, what's going on with the world? There is no fire. But what happens? I don't have anything on it for that. I have glass breaking. I don't have a fire alarm. I should have went and saw if they have it on Streamlabs. Smoke alarm goes off. Oh man, wait 2 seconds. Wait, we're gonna try this. I should have prepared for this example. I was not prepared. I was not prepared. Let's see. Music, sound effects. Alarm. Fire alarm. Oh my gosh, here we go. But you hear the following. But wait, you hear this. And what's going on right now? What's going on? What's going on? You look around. I need that over here on this now. Okay, so what is going on right now? You hear that going on. Can I not? I'll worry about it later. You hear that? You hear this noise. The really annoying noise. And what is going on? We're going to have to sit through it again. This is a type 1 error. There's no fire. Because what did it do in a type 1 error? In a type 1 error, the null is true. In a type 1 error, the null is true, but you what the null? In a type 1 error, the null is true, but you're going to what it? Repeat it again. In a type 1 error, the null is true. There is no fire. But your fire alarm does what? You reject the null. Great job right there, Carly. You reject the null, so the alarm's going off. And in a type 2 error, so this is our trick right here. In a type 2 error, the null is what? And we what it. So here's what you hear. You ready? Here's what you hear in the type 2 error. You ready for it? Here we go. This is what you're hearing in a type 2 error. This is what you're hearing in the type 2. I'm giving you a type 2 error right now. More specifically, this is what you experience in a type 2 error. So the null is false. So since the null is false, exactly. So Carly is explaining it too. The null is false. It is a false statement to say there is no fire, meaning there is a fire. So the null is false and we fail to reject it. We might, Cindy, that's a good question right there. We can put question 1, practice Josh. So the null is false and we fail to reject it. Oh, so sorry. I'm so sorry, Robert. Sorry to hear that. And that's a type 2 error. I mean, these are real world examples. So, what do you think? And this actually goes to the manufacturing of like smoke alarms. Smoke alarms would prefer to give you a which error? Which error do you think a smoke alarm manufacturer would prefer to give you? And Mayor Beth, you are right. We could do that, Vincent. They'd prefer a type 1. Would you rather wake up to a false alarm or fail to wake up to a real fire? So that's the way we could describe this. If we're at the company, we would say, unfortunately, we have to build our smoke alarms to be more sensitive. That way they would go off for certain if there's a fire, and they wouldn't fail to go off when there is a fire. So they might go off when there's not a fire, type 1. They might go off when there's not a fire, type 1 error. They will not fail to go off when there is a fire, type 2 error. And let me repeat that. We at our smoke alarm company are more likely to build our smoke alarms to make type 1 errors, where they go off and say there is a fire when there's not, type 1 error. We do not go for type 2 errors where they fail to go off when there is a fire. Oh no, Robert. Oh God, I was in the dorms? Oh no, that's really bad. Sorry to hear that. I lived in Grieve right next to Clement. Yeah, exactly, Matthew. It's like, because imagine if you actually did have a fire on your stove, like if there was a fire and then it didn't go off, you'd be calling them up and saying, I had a fire and my house about burned down and you didn't. Yeah. So, yeah, they're going to make them more sensitive to and make type 1 errors and false positives, because you would want your smoke alarm to have a very powerful test that would always tell you, yep, I lived in Grieve back when it was a dorm. Wow, it's like '07 now. It seemed like yesterday, but it's 15 years ago almost. I dream about having my dorm room as like my office. Let's make that happen. How long ago was that? I lived in Grieve from 2001 to 2005. Time travel and be like, what's up, Brian? I'll be like, who are you from the future? 2001 through 2005, I lived in the dorms. So back in the day. Vincent asks, let's put this right here. I'll put the question right here. Interpretations. I'm going to kind of go to some of our notes on this. So we'll put a break in the video right here. And a little bad about labeling videos. Let's do a little chill music right here. Let's go to our interpretations. I'm going to go to the sheets we have so we can kind of do this. Now, I've gone through interpretations on other things. Let's do confidential interpretation. Oh, heck yeah, we'll take that sweet DeLorean back to the past. So you got to travel back to past in style. What happened? Finch, what happens? Are my kids assholes? Sorry, I don't usually... If you want... I'm sorry. It's like... Those are the best lines ever. So, well, we get copyright claimed. Oh my god. So here we go. We gotta mute the music. Am I gonna get copyright claim for this? They probably haven't copyright claimed. They got like bad audio on this. This is Michael J. Fox, who I'd love to meet. Big advocate for but here we go. Let's check it out.
What are you talking about? What happens to us in the future? We become assholes?
So wait. Sure, Caroline, 2 seconds. Sorry. Oh man, sorry. You guys got me on Back to the Future. I love Back to the Future. That's one of the first movies I ever saw in theaters. You're like, that makes you old, Brian. But Back to the Future. Who here has not seen Back to the Future? We're gonna do the next topic here in a second. Go check out Back to the Future. Caroline, your wish has been granted. Go check out Caroline, your points again before it changes. Mubot will update them every once in a while. But oh man, I don't know if my fiance's seen them, but we should watch some Back to the Future. That's why I have the DeLorean and everything. Yeah, go check out quick. You gotta check those points quick. Oh, you should see 3. A lot of people don't like 3, but 3 really brings it all together. And they filmed 2 and 3 back to back. So someone's like, oh, 3 just doesn't make sense. Now they filmed 2 and 3 back to back. Like it was before like The Matrix did 2 and 3. Back to the Future. Yeah, the Back to the Future is so good. Like 2 might be my favorite. Movie 1 is about Marty. Movie 2 is about the DeLorean, and movie 3 is about Doc Brown, Christopher Lloyd. Wait, yeah, Christopher Lloyd. Engaged, but not sure if. Yeah. I think it's one of those movies, like we talk about like Batman and stuff like that, and she's often like, I don't want to make. I'm like, I love Back to the Future. Like, what did we rewatched something, because I was like, I could just rewatch this at any moment. It was so good. Oh, Rick and Morty. We started Rick and Morty from scratch. Two's your fave. Two might be my favorite too, because no, but three was the first one I saw in theaters. I don't know if I saw them in like reverse order, because I saw three when I was like 7 or so. Are you going to be in the? I hope that'd be really cool. I might have to wait. Has anyone seen real quick on this? And then we're gonna do interpretations. Has anyone seen the new Spider-Man? The new Miles Morales preview? We're gonna just view that for a moment. We're gonna just get hit with the new Miles Morales stuff. God, looks so good. First look, Spider-Man. So I'll put it on the screen behind me so maybe we don't get copyright claimed. But go check this out afterwards. The new Miles Morales. If you have not seen Into the Spider-Verse, absolutely awesome. I'm gonna disappear, but you got to go check out Into the Spider-Verse. Miles Morales. Across the Spider-Verse. Absolutely awesome. I'm pretty sure I know who he's going against here, but the art style, the everything, you got to go check it out. Absolutely awesome. Across the Spider-Verse. If you have not seen the first Spider-Verse movie, let me just say this. What's his name? Oh gosh. Oh, why am I forgetting the new guy's name who's Spider-Man? He does such a great job, but Miles Morales, Spider-Man, has put such big shoes out there to fill with the Spider-Verse movie. But yeah, so those are so good. Tom Holland is great. Tom Holland does a great job. Sorry, Andrew Garfield. I know you tried, but I think the writing just failed on those movies. And of course, Tobey Maguire, who doesn't love Tobey. And Spider-Verse is such a good movie. You even got some Nick Cage Spider-Man. Not trying to, no one much so much out there, but you check out the movie because you're going to see a lot of amazing things. You check out some Spider-Verse. With that, the Spider-Verse sounds so good. Oh my gosh. We went to see it because we're like, it looks good. We like animated movies. And then so this is the last thing right here. Bully McGuire. Yeah, Bully McGuire. Just, anyway, so yeah, Connor Moore. It's so good to see you, Connor. When we saw Spider-Verse, we walked out of the theater and my fiance goes, that was amazing. I was like, yeah, it was amazing. And she goes, it was better than Deadpool. And I paused and she's like, you're thinking, right? And I was like, yeah. And she goes, that means it's better than Deadpool because I love Deadpool. So I was like, yeah, it was better than Deadpool. It's definitely better than Deadpool 2. Sorry, Deadpool 2. Deadpool 1's way better. Anyways, let's do some interpretations. Here we go. Oh, I've heard of that too, Chloe. Good suggestions, Chloe. Thank you. Put those suggestions out there. Dances in Destiny. Oh man, maybe I should play some Destiny 2 over break. I've been playing too much Isaac lately when I have spare time. Okay, yeah, of course. Hunter asked that question. We'll throw that in here because we can get some 320. Hunter, jump that question in. We might even have it jump the line a little bit. So Hunter, please ask the 320 question. Back to reality right here. Here we go. So when you do a confidence interval, there are how many components to give in a confidence interval? When you do a confidence interval, you should be thinking, I need to give my 3 components clear and concisely. I should check out. Oh yeah, people have been saying I should play some Halo Infinite. I got Steam on here. I might game over break. Who knows what I'll do? Connor, so good to see you. I'm throwing 100 points for Connor appearing. I miss Connor swinging by my office. This right here, Macy, this kind of interpretation. How many components are there? We're putting on that serious face. How many components are there to a confidence interval interpretation? You can see the answer on the top of the screen. I just want you to acknowledge it and you to think it over. I need to put these through your head right here. Some people, I think I've heard people say there's 4. Rad right there. I'll play Rad or Brad. Kind of, I think I know where you're going with 4. So some points out there. Kind of. I like to say there's how many components. View the top of the screen, then I'm going to talk about these things right here. No, you're good. You're good. I think the notes might say there's 4 because they might break apart these 2 right here. I think they might think of this as 2 separate components towards the end. I like to think of it as you're just giving the interval. Does that make sense? So I say there's 3 components. Some people might say there's 4 because the interval has a lower and an upper. Does that make sense? So the breaking apart, which Brad, we're here to throw out points when you give answers, and that's what we're here to do. Don't worry, I'm sorry, I'm just Brian. So some people break apart this into like the lower and the upper. Brad, thank you so much for those answers. And we're just here to practice. That's what we do. So some people break this apart into like a lower upper. So some people might say there's 4. With this right here, I am blank % confident that the true, and then throw in a true. You can say that that is correct right there. That the true something is contained in the interval blank to blank. So you have to be first. Let's identify the level of confidence. and the level of confidence will always be shown to you in like a screen right here where we have the level of confidence. Just take that number directly right there and state that you are this % confident. The hardest part for people is when we get to this component right here. This is where the errors occur. So we usually have people making errors right here. Can I go to the home and remove this? This is where people get confused. And I'm even going to do this right here because people, this is what you would have. Let me blank this out and show you what this would look like. I don't want to do that. Your interval when interpreting will follow this format pretty much no matter what. Here is the way the interpretation looks. So take a screenshot of this and know this. I think a lot of people do. It's just the practice. It's probably the best way I can display it right here. Does this make sense to everybody right here? This is what the words that always exist. So these are the words that exist, but you then have to figure out what goes in there. The hardest part for people a lot of times is the second component. I'll get to that here in a little bit, Tanner. Remind me of that. I think is that the 320 question? I think. Yeah, remind me of that. We'll do that next. I think if that's the 321. The only way to decrease the probability of a type 2 error is to increase the probability of a type 1 error. Oh, that's false right there, Tyler. That'd be false because we could increase the sample size. There's 3 things. So let's try one of these. Let's try one of these and see if you could get it. I will grade your question here live. So I'm going to grade your response here live. We'll do an easy one and we'll do a hard one. Let's go for what I consider an easier one. This is an easier one. I'm not saying it's like, oh, the easiest question ever. But let me take an interval right here. I consider this an easier interpret the confidence interval. Please note it is age. Well, sure, I'm going to highlight what I want you to interpret. So it's on the screen fully in case anyone goes to a later portion of the video. I consider this a bit of an easier interpret the confidence interval type question. So this is what I would say is an easier confidence interval. Interpret specifically this one over here. Take a moment. This is your practice. Try to solve it. When we interpret it, we always, and so this one right here I think I know what makes these asking. This is a confidence interval for the mean. So this is how old are people on average. And so we would not turn this one into a percentage because it's based on a quantitative question. So the only time we turn to percentage, close, Catherine, that might be 3 out of 4. There's a small portion missing. Graders might even get 3.5 out of 4. I think Olivia got it right there. And I might reverse the lower and the upper, Olivia. Great job. I'm throwing 100 points. All these people practicing right here. And so I'm going to pick one, I think. And so I just want to say thank you for all the practice, especially if you jump first. Oh, and actually, Trevor and Olivia, I tricked a bunch of people. Please, people start spamming in the chat. There is an error to the early interpretations because I did another trick to this. Please, everyone note the error that a lot of people are seeing that I didn't catch and I purposely put in here. What error is there that I forgot to mention? Tyler's seeing it. Trevor's seeing it. Great job. Both Tylers are seeing it. Both Tylers seeing it right away. This right here is the confidence level. We could highlight it in blue right here to make it a little more apparent that this is the confidence level right here, and that's the interval. Now, what we're talking about, and we're trying to highlight by the same colors right here, what we're talking about is the true mean of age. So if you notice right here, I've got the highlighting. Anyway, if I do this. There we go. Yeah, exactly, Matthew. Great catch right there. The alpha is the confidence level. And so that's where we can get the information. So you get the percent certainty from the alpha, 91.2% confident. It might also state it like the other interval. You could interpret this one right here, and I would carry all the decimals you see. If I see decimals, I'm going to do it. Carly and everybody, great practice. I am 91.2% confident that the true mean of age is contained in the interval blank to blank. Now, why do we know it's mean and not proportions? Everyone repeat, why do we know it's mean and not proportions? Because people are wondering, well, why didn't we say proportion? Why did we? Very good. That is correct. Why do we know it's mean? And so you see tons of great answers in the chat. Those are 4 to 4s. A lot of those are 4 to 4s. And is the average age? That is correct, because age Quantitative histogram's a good answer because histograms are for quantitative. Exactly. So when we do quantitative, we would get them, and also it says mean. That's a good hint right there too. It says mean, and you're seeing a lot of means on the output because age is quantitative, not categorical. Does that make sense? Why it's going to be true mean? Here we'll do another one very similar to this, which I would say is of the easier difficulty level. Oh my gosh, we're going to go towards the easier difficulty again. Analyze distribution. Sure. Okay. Sure, why not? Easier to click in. Okay, interpret the confidence interval. Remember, use this format. Interpret the confidence interval over here. A little chill music again on. I'm going to put on my actual chill music. No, I want this one, I think. I mixed up my songs and I forget which ones I like. That's the one I want. I want this one. This is nice and chill. You can say difference between the two means. I'll be doing that one here in a moment, Finch. And I think it's the question from 320. I want to do that next. So we'll do the 321. Got to give a shout out to some 320. And I want you to interpret this interval right here. Let's break down the components of what we have right here. I'm going to highlight the colors for each one. I'm giving hints, so if you're stuck, I'm kind of highlighting the important components. And then you have to think how they relate. Well, yeah, Tara, that's a good question right there. We'll do some of that. You will look at some jump output, probably. Yep. Trevor, that might be 4 out of 4. It might be 3.5 out of 4. I think Tyler added on some extra stuff right there, which is great. So it's really close, Trevor. I would just add in, because it's right there, Trevor. Shout outs to Trevor right there, first to answer. So always like, can't see what other people are answering yet. And I think, so I see a lot of great answers here. I'm going to read one of them. We can say we are. We are is fine. You can say we are. I like to say I am. So I'm going to read Brad's answer right there. We are 90% confident that the proportion of students who have student loans is between, and I like to say containing the interval. Brad, great job right there. Shout outs to everyone giving some answers. 7, you could leave it as a decimal or change it to a percentage. And make sure, I see a few people using you can do the no. And I see Sherry, great job right there. Sherry did the no interval, which you can do. Now make sure you do 90% confident because that is the confidence level associated. And we've got coloring right here to kind of highlight. Thank you so much, Brad, right there. I'm going to go out on a limb and just make Brad a mod. Brad, shouts to you, Brad. I appreciate it. Brad, you're now a mod on the channel. We are just happy to have people here. About that positivity, let's do another one right here. What do you think I'm going to do next? Which we could also do a confidence roll. Now, we can't do confidence roll for chi-squared. So what of the remaining ideas have I left out here? What of the remaining ideas? Like, I've got some good statistics right here. So what of... let's go! So what of the remaining ideas have I left out? Who knows what remaining idea we have not talked about for confidence rolls? Yes, Carol. Check out Sherry's answer, Caroline. Great question. What remaining idea? Because this was categorical. Yeah, graders should be fine with either one, Olivia. That one was categorical, Sam. So this one is categorical because we're asking, do you have student loans? So it'd be the proportion of students with student loans. So this one's categorical. So does that make sense to everybody? The difference between the top output right here is that is categorical, and the bottom output is that the bottom output is quantitative. So this one, when you have age, it's quantitative, and thus we would talk about the true mean. The top one right here is categorical. Do you have students' loans, yes or no? So having students' loans, yes or no, would be the true proportion of students with student loans. And so age will be true mean, the true mean age of students. And always do this. Don't worry, I've been doing stats a long time. Always like say it like the true mean of yes students. Then you'll be like, something doesn't sound right. Or the true proportion of age. The true proportion of age doesn't sound right, but the true mean of age sounds right. The true proportion of students who have student loans sounds right. I know I've been doing this a long time, so these things sometimes make more sense when I say them, like when I hear it. But try reading it out loud, and if what you say makes sense, at least to you, then you're probably on the right track. I do realize the stats words have been floating in my mind for a long time, so they sometimes connect a lot quicker. But no, great job. Great job, everyone. So what is the one we're missing, though? What are we missing right here? Who knows? For some points in the chat. What interval have we not talked about? What interval interpretation have we not talked about? Great job, Olivia, right there. The difference between two means, which is the 2 sample t. There's 4 interpretation questions. There's 4 interpretation questions. We have not talked about the difference between two means. So this is a 2-sample t-test. Let's see right here. Have you drank? I think it's just have you drank. And then let's look at the age of students and if they've drank. If students have drank, I think it's just have you drank. What would you expect would you expect there to be a difference in the age of students if they've drank alcohol? So now we're doing a 2-sample t-test right here. And we're going to look at the age of students and if they've drank alcohol. Would you expect there to be a difference? If you're in the United States or you know our laws, you would expect. I mean, I don't know why we have any answers right here. I'm just kidding. So you can go into jump and go right here. Tell me about these individuals I'm highlighting right here. Please drink responsibly. Be safe. Drink responsibly. Tell me about the individuals right here. Tell me what's going on. It's real data. That's how data do. Tell me about that right there. These would be people classified as what? Tyreek right there. They have drank alcohol under the age. But here's the weird thing. I think in Texas, you can actually go to a bar underage and be served alcohol if you're with your parents. I'm pretty sure that's the law in Texas because, one, people like to say it because it's pretty interesting that Texas has that kind of law. But two, cold Tyreek killing me though. That's what we call the grand mean. Don't worry, that won't be on the test. Thank you so much, Caroline, for asking what is that line right there. I'm throwing Caroline for asking a question that goes beyond the test. We call this the grand mean. The grand mean is the mean for all the data. So that's the mean for all the data. That's you don't have to know what the grand mean is, but that is what we call the grand mean. So just some jump knowledge right there, or output knowledge. We call that the grand mean. So the average age of all individuals is about that. We'll go to the actual test right here rather than look at the data, but I do love just examining data. So what do we have right here? Let's first talk about this output just for a moment, then we'll interpret the interval, and then we're doing a 320 question real quick. What does this mean right here? Let's bring it over to Word so we can work with it. What does that value of 0.4 mean? Maybe I shouldn't do it because it's not the interval interpretation yet. What is this value of 0.4? This would not be included in the interval interpretation. I don't want to confuse anybody. What does that 0.4 mean? And so it's important to understand what's going on here with the interval, and we'll zoom just in on this portion. What does that 0.4 mean? Which would not be included. I'm just kind of getting an idea of what's going on with this data right now. What does that 0.4 mean? It is the difference of the mean in the two groups. It's what we saw in our sample. It's the difference between the ages we saw in the sample for the yes people and the no people. So this difference of 0.4 would indicate that which group was older on average. The difference of 0.4 would indicate, not that yes has more people, but the mean for yes was what? You got this, Campbell. Everyone give some shout outs to Campbell right there. Campbell, you got this. You got this. You got this. Just be like, I'm gonna ace this. You got this. The mean for yes is higher. If this difference is positive, then it is that this difference is the higher one. If the difference is that the yes, if the difference is negative, then it's that the second difference, which we don't see a negative here, but if it was negative, it would be that the second mean is higher from the sample. So when we go through this right here, let's look at our interval now. So the interval right here shows us these values. And we are talking about this. And I'll just use this. Please make sure to check it. We can change it. So who wants to take a stab at the really tough one? I'd say this is the toughest one, where it really is just... That's all right. No, we don't know. We don't know till the end. We don't know till the end. It's not the end yet. It's not over till it's over. So how would this be? This is the toughest one I'd say to interpret for confidence interval interpretations. I've highlighted the important parts of the output that our eyes should be drawn to, and I've got the color coding to help out with where it would go. But you don't want to say that the true yes minus no. I'm 95% confident the true difference between ages versus the people that have drank pretty much. And then this would not be multiplied to a percentage. This would not be multiplied by percentage. So Michaela, it's probably 3.5 out of 4. This is the toughest one. This is the toughest one. Bruh. And then these would not be percentages because this is quantitative. So these would not be percentages. We're talking about the difference in ages. I'm 95% confident that the true mean, but the true difference between... So the way to tell it's a difference right here, I'm going to point to this. The way to tell it's a difference is it's a 2 sample where we're doing the difference. So this is the difference between the two means. This is the toughest one. Finch. I'm giving 100 points for Finch right there. Shout outs to Finch. Great job, Finch, on your econ. I am 95% confident, but not proportion because it's means, it's quantitative. Because we're doing a mean, we're doing the age of individuals. So you have to ask, is it quantitative or categorical? I really like the way we're asking right here. And don't worry, this is probably the toughest one. I am 95% confident that the true difference between means and students who have drank and who have not drank is contained in the interval. Olivia, that might be 4 out of 4. Depends on grader. Very close, very close. Great answer. Great answer. Toughest question on interpretation for intervals. Great answer. I am 95% confident the true difference between ages of people who have drank and who have not drank. But don't multiply it to percentage because this is quantitative. Let me give the answer. What would I put? That's such a great question right there, Caroline. So this right here, I am... Oh my gosh. True difference between people who have drank and have not drank, because that's what we're doing up there. The people who have drank and have not drank is contained in the interval. If you're worried about turning things to percentages, just don't even change it, because this one would not be percentages because it's quantitative. And if I'm doing the test, I'm probably going to write this out. Like I'm going to put every number just so the grader doesn't get mad at me for a rounding issue. This is how I would answer on the test. And right here, between the true difference in means. There we go. Sorry, I should have added that. I am 95% confident. I got to get that 102 right. I'm 95% confident that the true difference in means between mean ages. Mean age. There we go. Might be grammar issue. Okay, so this is I think this is my final answer. Let me read it. I am 95% confident that the true difference in mean ages between people who have drank and not drank is contained in the interval blah, 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 to blah, blah, blah. That's going to be right there. And then make sure to say mean ages, because this is the mean ages. We don't have that at the top. The question would give context, but we were looking at the ages of individuals. So I'm 95% confident, and I see a lot of great answers that probably are some 4 out of 4s. We're just looking for how close you get to something like this, and they make they'll kind of be a little nice on it sometimes. If you feel they're mean, just talk to me about it. There are answers that are pretty far off that I've seen. So some people, the graders, luckily some graders are already working on grading, so shout outs to my graders. I am 95% confident that the true difference in mean ages between people who have drank, the yes group, and you see that up here, and people who have not drank, that's where I'm getting this context from, is contained in the interval. And then the interval, best thing to probably do is not multiply it. So here's Brian's advice. Teaching to the test moments. If you're worried about if you should multiply, just don't, because there are instances where you will not multiply. Does that make sense, everybody? If you're worried about, do I multiply this by 100? Don't, because even if you're saying proportion, like just use proportion and not percentage. For the last example, do we make it a percentage or just leave it as decimal? Either or is fine. So to go back in time right here, the last example could be done either way. We're going to have to swing way back in time. The last example, not this one. Oh, we might have lost that last example. Let's pull it up and jump right here. This one right here could be done either way. I've lost my time travel abilities. The DeLorean's out of service. This one right here could be done either way. That is not the proper interpretation. So let me cover it up. But this one right here could be done either way. Does that make sense? This could be, I am 90% confident that the true proportion of people who have student loans is contained in the interval 0.4648 to 0.52227. I am 90% confident that the true percentage of people who have student loans is contained in the interval 46.48 to 52.27. This one can be multiplied by 100. If you're worried, probably don't multiply them by 100. It can be multiplied by 100. Why? Because this is what's. You can multiply this one by 100s because this one is what's. You can if you wanted because this one is what's. So you could multiply this by 100 because it is what's. It's categorical, it's proportions. Exactly, Giselle. Great answer, Giselle, right there. This one's proportions, and then the previous one, the one we just did a moment ago, was means, so we can't multiply by 100. You wouldn't multiply, even though these are decimals, these are differences between the average ages of both groups, and this one you would not multiply by 100. can I multiply, and then obviously the answer is going to be a little more obvious right here, can I multiply these numbers by 100, which goes off the same as the last one. Good job, remember Matthew. Can I multiply these by 100? Would that, it doesn't even make sense when you do it. And why can I not? I'd probably just stick to decimal. It's a good, like, because there can be the wrong time to multiply it. You can multiply in some instances, but if you want to be safe, probably don't. I'd say my advice is the safest to keep it as decimals. And this is quantitative, so we wouldn't multiply by 100 either. We're going to do a 320 question. We will do a little more 201 after this. I'm trying to find, if people can help, I'll throw 100 points. I'm going to scroll down here in a moment, but do people have the question from my 320 student? I want to give shouts to all my students. We're here to help everybody. We got a lot of 201 students, but I always want to help out every student. I am scrolling through the chat right now. I'm going to see if I can find it. I wish I could just control F through the chat. You know what I'm going to do? Watch this. I'm going to, let me see. Hopefully we didn't lose it. Okay. I'm going to go and take everything. I'm going to, oh wait, is this, oh my gosh, Hunter's here. Thank you, Hunter. Let's do this. Hunter, 100 points for hanging out, sticking around. And also, I'm throwing another 100 points for Caroline helping out. I want some vols help vols in the chat right there. Thank you, Caroline. Some vols help vols in the chat right there. Caroline, thank you so much. Hunter was here to help out with the question, but Caroline too, dropping that question is the difference. Let me grab this right here. I think it's for the take home, right? It's for the take home, right, Hunter? So put it out here in video format a little bit. I think Hunter's asking a take home, which is fine. I can't answer directly, but I can kind of, I'm going to talk about it a little bit here. What would the last interpretation be? We put in, check it out. I wrote it down right there. So Sandra, check out we put it down, but check it out, or which one are you talking about? We can make sure we put it in the chat. Let's go check out Hunter's question right here. Is the t-value the difference between the standard error between the two levels of a categorical variable? So this is kind of a good crossover between 201 and 320. When we do, make sure, I don't know what I have up in R right now. Oh, there's Discord. Okay, cool. R is blank. That's usually try to blank it out and restart it. Okay, so when we do, so let's go here and make a model. I restarted R apparently. Okay, height. So we'll tilde handedness plus gender plus weight plus desired weight. Data equals survey 10 and summary. Okay, so we were actually talking about t-statistics earlier, and here is a t-statistic. Now, a good thing for 201 to know, yeah, do some chi-squareds. 201, if the t-value is larger, what do you think happens to the p-value? So this is a 201-ish question, which is true for the chi-squared. If the t is larger in terms of absolute value, what happens to the p-value? Like if the t is very small, but if the t is larger in terms of absolute value, then the p-value will be water, which is true for the chi-squared too. If the chi-squared can only be positive, if the chi-squared is larger, or if the t is larger in terms of absolute value, because we're just talking about the absolute value of t, the p-value will be what? Yo, Libby, good to see you here. If the t is larger in terms of absolute value, the p-value will be water. So if the t is smaller, the p-value will be thiser. So if the t is larger, the p-value would be water. I'm trying to wrap in a little 201 knowledge into this. Works for chi-squared too. If the chi-square is larger, the p-value will be smaller. Does that make sense? So these things are inversely related. The larger the t-statistic, the less likely it is by random chance. T's are just like Z's. When you think like a large Z-score, think of a large T-score. That's ridiculously large, i.e. small p-value. This is very small, i.e. high p-value. T is larger in terms of absolute value. So Mary, good answer right there. When the t is larger in terms of absolute value, and do you see the absolute value right here? Because t can be negative or positive, it's just the further it is away from zero. The smallest t is 0. More extreme values of t are negative and positive on the extreme ends. Like you could go further away from the mean on the low side or further away from the mean on the high side. So right here, you'll notice this is negative, but statistically significant. This is positive and statistically significant. It doesn't matter. If it's positive or negative, it's just the further it is away from zero. So the most significant was this one because it's the furthest away from zero. The more extreme the t, or actually the intercept's the most significant. Aubrey, which one, if you want me to say which one it is, I think you're talking about the 2 sample t. Check out, we wrote it out in the chat and we wrote it out on the screen. So Aubrey, check that out and let me know if you have questions. So to the question specifically, the t is not going to be a difference between certain things. What we have right here in this output is our estimates of the weights of things, like going through the whole output. Like I don't want to directly answer, but I want to top of the output a little bit here. This is our estimate of the intercept. Now, what this would mean, this would be somebody who is ambidextrous, who is female, who weighs 0 pounds and wants to weigh 0 pounds. The intercept is when everything is equal to 0. Now, what's really tough about this, at least for 201 right now without this knowledge, is, and I think it's Hunter asking, Hunter, I have just removed all the what's from this model. What did I just removed? So it was 1 sample t, 2 sample t, and proportion. 1 sample t, 2 sample t, proportion. There are more interpretations on tests. We just did interval interpretations. We just did a big review of interval interpretations. So Hunter, what have I removed out right here? I've removed out all my what's. Caroline, great job right there. And Hunter's correct, and Caroline's correct too. We removed out all the categoricals, and the categoricals create what kind of variables in the model. Categoricals create what kind of variables. So Caroline, amazing work right there. So we're throwing out some big points today. Caroline, great practice. We took out all the categoricals, and categoricals create starts with an I. I'll try to move things along. Yeah, no, you get it. It comes down to variable types. It literally comes down to variable types here. Because when categorical variables are introduced to this model, which we break the QQ, but we fix it with a trick, we are creating indicator variables. These are indicator variables. You'll notice right here we don't see gender female because gender female is the reference level. Does that make sense, Hunter, especially? And these are indicators, yep. So gender male, I'm still on top chat. What am I doing with my life? Gender female is the reference level and gender male is the indicator. The reference level is the first alphabetical. So up here, just take a moment. We're missing which level of handedness? Hint, right, left, starts with an A. We're missing ambidextrous. The level ambidextrous is in the model. It's just the reference by which things are compared to. So it's not, reference isn't really built into the intercept. It's just that the value of the intercept would be when all the quantitative, Hunter, actually, I kind of agree with you. It is kind of the intercept, but it's not like, it is like the intercept. When we're talking about the intercept, that would be when someone is at the reference level and all their quantitative values would be equal to what? Just put one number in the chat. If something is at the intercept, it would have to be they are the reference levels. They are ambidextrous. They are female, which is the reference level. And then also their quantitative values are equal to what? Because they're the intercept. So their quantitative values are equal to what? Basically when everything is equal to this, which means they're at the reference levels. So they would have to have quantitative values of weight and desired weight to be the intercept equal to 0. So the intercept's usually not of significance because it would be someone who is ambidextrous, someone who is female, great to Hunter right there, and somebody who wants to weigh 0 pounds, who does weigh 0 pounds. Hashtag don't do that. So with this right here, we know what these estimates are. These are kind of the coefficients for the model. They're the B1, B2, B sub I, whatever estimate we're talking about. I think the big thing we haven't talked about right now is the standard errors. The standard error is a measure of what? It's like your what for the variable. It's going to create confidence intervals, which we literally can bring this back to 201 right here if we run the following code. And watch this. I'm going to write 2 numbers in the chat for you. I'm going to write negative. Let me store it right here. And this is a really good question, Hunter, that I can solve. And I just want to show 201 why their knowledge is so important for what we're doing in 320. So I want you to see those numbers I wrote right there. And now I want you to remember those numbers. Oh, I didn't close it. Oh, I have a... So there's my numbers. And how in the world... Oh, we didn't remake. Let me make the other model. Ooh. Go grab the other variables. Gender plus handedness. There we go. If you look at my values right here, did I do it right in my head? There they are. Here they are. Oh, I didn't put negative on this one. Darn it. So let me reverse the order, and I should have put a negative on that. Negatives are bane of my existence today, apparently. Do you notice the output right here? And my estimate. There's my estimate, and I was able to figure this out. So with this right here, I'll talk more about this in a moment, but the standard error is just a measure of what in this value. The standard error is just, think of a U word. The standard error, and I'm getting to the big point of the question right here, the standard error is just a measure of what? I'll probably say it because I know we only have 1 320 here. It's a measure of uncertainty. And when we build a 95% confidence interval, we basically go out, stat 201, big thing for you, how many uncertainties? When we build a 95% confidence interval, we basically go out how many uncertainties? When we build a 95% confidence interval, we basically go out how many uncertainties, because the standard error is the uncertainty, and we've seen this in 201. We basically go out how many uncertainties building a 95% confidence interval. 201 can answer is 2. So we go out how many uncertainties when building it. This is a good teaching the test 320 moment right here on how to make a confidence interval with kind of using the numbers. 2, great job, Sam, right there. We got 2 with 68, 95. And so what we can do right here is what is 6? This is basically 6 times 2 is 12. What is 12 plus 26? I'm rounding this to 26. 12 plus 26 is negative 38. We're actually going down. What is 26 minus 12? 14. This is what I did right here. I called this 6. I called that 26. I times 6 by 2. I added it to 26. I got 38. I subtracted it. I got 14. And that's how I'm solving the interval right here, which it gives me in the output when I solve it using software. In the upper level classes, we don't solve these things by hand. What we need to know is what these values mean. They're measures of uncertainty in our estimates. So when you look at hint, 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 when you look at something like handedness right here, that is your uncertainty comparing it to the what level. Because when we make the estimate is its difference from the what level. But then our uncertainty, the standard error, would be our uncertainty of its difference from the what level. So the standard error right here is a measure of uncertainty of the estimate of handedness's difference, because we have an estimate of the difference of handedness from its what. Let's go back to the original stuff we're talking about, because handedness right is a coefficient for its difference from the reference. So then the standard error is our uncertainty of our estimate of its difference from the reference. Now, I didn't quite answer the question directly, I hope not, but is it making more sense what this output says here, Hunter, and how the standard errors are the estimates of the uncertainty from the difference? The t-statistic is a standardized metric. It's a test statistic, which is the estimate divided by the standard error. You can solve if you divide those. T-statistic is a standardized metric to talk about how far something is away from our hypothesized value. The standard error is the measure of uncertainty comparing in indicators something to the reference level. Good stuff. We got a few more questions. Thank you, everyone, for hanging out and doing some questions. We're going to hop back here to 201. Are you good, Hunter? Everything good? We'll check back on the main screen. Turn on the AC. How's it hot in Texas? Oh, that's the answer. The answer is the question itself. How is it hot in Texas? It's the answer to the question. I'm going to grab something from Discord right here. I'm going to grab my cheat sheet for conditions. We didn't do interpretations on the test, like on testing stuff. Hunter, thank you so much. Shout out to Hunter right there. Some points in the chat. And we just more interpretations for a moment. Might end with that. Good question. Let me go grab from the Discord. Where's my Discord? And then I'll have to go probably and answer. People tell them bachelor discussion. I love it. Set to in general. Someone tagged me. Oh, wait. People go to rank check. Also, awesome. Member hashtag rank check for checking ranks. I'm gonna remove so people don't see it. Delete. Just there is a rank check channel. Yay, rank check channel. There's a rank check channel. Okay, there we go. Let me grab the picture that we show. So close. Where is it? Almost there. Exams are almost over. Then the grading begins. And I'm going to try to grade and have everything graded up for the weekend. That's our goal. Here we go. Found it. Okay. Take a picture of it and bring it over here. Okay. Took the song this time. That's fine. Okay. Let's go over to the main screen and check this out. And here we go, Vincent. Let's talk about the conditions. Here we go. So what are the conditions we just fly through? And we should know those decently. So this is a good way of knowing your conditions right here. I highly suggest having this written down. So I have some color coding right here for what's going on. Let me add a little more notes to this. The color coding for the green is categorical. And the color coding for the blue is quantitative. And that means this is quantitative. And the color coding for the last one right here, the orange, is chi-squared. So chi-squared. Sure, chi-squared. People might know better if I don't do the chi. There's not 4 intervals. There's 4 interpretation questions. There's 4 interpretation questions. Some of them are on testing. We didn't do any testing interpretations today. We have done it previously and throughout the semester. So there are 4 interpretations. Some of them are on testing. There are interval interpretations, and there's some on testing also. So with this right here, when we go through this interpretation, we always go through randomly selecting the data. So we randomly select our data. We have to sample less than 10% of the population, and then we get to where. Then we pause and we stop and we ask ourselves, is our data categorical, quantitative, or are we doing the chi-square test of independence? So you basically need to have a tree right here. Can you do it? Yeah, I'll do it. I think we might do that. We got a few more questions. We'll probably do that. We might end with that here. We've been going for an hour 20 or so. So when you get to this right here, how will you know, like, how many conditions? Just try to do this right here. How many conditions are there for this? How many conditions are there for this? We are testing to see whether students have student loans. How many conditions are there? We are testing to see if students have student loans. How many conditions are there? Just start me off with that. There's 3. And what would the third condition be? Now, student loans is a categorical variable. Since student loans is categorical, so we go right here, student loans is categorical, you would stop right here. Does that make sense? Success, failure. Are there at least 10 successes with the student loans, at least 10 failures? So that is where we'd go for this one. How about the following test, where we were testing do students, or how old were the students who have drank alcohol? Now go through the steps. Can we get it on the screen at the same time? We can almost. So the first step, we know condition 1, we know condition 2. We get to here and we ask, is it categorical or quantitative or chi-squared? So we're asking the age of students. So which of these things do you think it is? We're asking the age of students. Now we go to nearly, and do we stop there? Trevor, you are right. Hey, Lucy, great to see you here, and great job, Lucy. So, and if Lucy, if you have a question for 474, 475, let me know. I think you're 474. We did 320 just a moment ago. So it is quantitative. It is quantitative. And so it is nearly normal. The third condition will be nearly normal. Do we stop right here, though? Do we stop on the nearly normal? And nearly normal can use large enough n. The condition is nearly normal, but it can use large enough n. The condition is nearly normal, but it can use large enough n when we're testing the mean. It's just a way of passing the nearly normal at this point, because the condition is this. Oh no, no buffer. I think no buffer. Lucy, you show up and there's a buffer. No. Good. Lucy, congratulations. 100 points to Lucy right here. Shout outs to Lucy. So honored, Lucy. Doing a great job right there. Thank you so much, Lucy. Be careful on the output. So we're asking, we're comparing the ages of students who have drank and have not drank. Are there 2 variables here, yes or no? All right, Lucy, right? I need to get new internet. I looked into Starlink and I can't get it till like we're leaving Texas. There are 2 variables. Hey, Harper, great to see you here. There are 2 variables. There are. Yeah, Trevor, don't worry. This is the practice. Yeah, and Sherry, let me know if there's issues. We'll get it fixed up. I know you're I know why you're going around and stuff. If there are issues, we'll get it fixed up because you've informed me of these things. So don't worry. If something crazy happens, I'm in the loop, so you're good. And just say, hey, Brian, like send me an email and say, hey, Brian, the things are messed up, and we'll get things worked out because you've kept me very in the loop on this. So the answer is there's a categorical and a quantitative. So what would be the 4th condition? What would be the 4th condition? What would be the 4th condition? So the 4th condition would be what? So chi-squared works with categorical data, right? Is it count data? We need independent means, exactly. That means, wow. Owen Wilson jumping in there on The Rock. You're welcome, yeah. Thank you for the communication on that. Then I'm definitely well informed of what's going on. And that's why we opened up a little more, because we don't want to deal with, like, we don't want there to be problems. It's, because I'll need to jump off here and look at some emails to make sure everything's on track. We want there to be independent means. That means the people's age of drinking who have drank, or the people's ages for those who have drank, is not going to impact the people who have not drank. When we have non-independent means, it's usually a before and after. Something like, imagine if you cook a bag of popcorn kernels twice, and you look at how many popcorn kernels are popped the second time you cook it. So now you have the first time you cook the popcorn bag, how many are left unpopped, and the second time you cook it, would those be independent or dependent means? You have the mean amount that are left unpopped the first time you cook, and the mean amount the second time you cook it, and you're going to compare these to see if there's a difference. Would that be dependent or independent when you pop popcorn bags 2 times? It'd be very dependent. And just like say it to yourself this way: when I cook the popcorn bag the second time, the amount of unpopped kernels would depend on how many were unpopped the first time. So the mean for the second group is very dependent. Exactly. So in our example right here, we would not have dependent means because people's ages in the yes group are not going to depend on the people's ages in the first group. So there's usually before and after, like you do something twice or something, like a retest thing is a dependent mean. These are independent means right here because someone's age in the yes group would not depend on the age in the no group. So those are independent means. The last but not least, or example we have right here, is the chi-squared. And we do have a chi-squared up. So we would have to go right here and see if there's at least 5. Just take that out. Lucy, you're awesome. The count data. So why are we doing count data here? Chloe, great question. So Chloe, why would this be count data? So right here, and what is count data? So this would be condition 1, random. Condition 2, less than 10% of the population sample. Condition 3 is we have to have at least 5 expected cell counts. So all of these expected values right here, I'll show only the expecteds. All of the expected counts, which we do pass, all of these expecteds right here are greater than 5. Why is the 4th condition right here? And bivariate categorical specifically. It is categorical. So by virtue of having this graphic, by virtue of doing the chi-squared, as Trevor points out right here, we have 2 categorical variables. So the condition might as well be called CC because it's 2 categorical variables. So it makes what we call count data, and you can see the word count right here. CC, great job right there, Muhammad, and everybody. The count data condition means bivariate categorical. And if you had to explain this, you would say smoking weed is a category yes, no, and drink your water habit is categorized into groups. Thus, we have 2 categorical variables. Thus, the count data condition is met by having 2 categorical variables. So you literally can't do the chi-squared test of independence if you don't have categorical data. You wouldn't be doing it. Good tools and techniques question right there. Let's see. So that's the conditions. My gosh, what's going on with our Word documents? We need more. Always need more. Open all the Word documents. Conditions. Question 1 on the practice test. So question 1. Oh, we got 2 question 5s. How is that possible? Can we go over reading chi-squared jump output real quick? Yeah, we can do it here. We'll put that. Might be one of the last things we do. Reading chi-squared output. Yep. Let's see right here. There we go. Let's see. We are doing conditions. So question 1 on the practice test. 2 seconds. Let me get that up and going right here. And we have review 3 posted. So I'll be ending this video here soon, probably next 20-ish minutes. So if you haven't seen it, we have the review page. There's one for each test. I want to set this up for 320, 474, 475. It'd be good if we could standardize. Made this webpage a while ago now. It's like forever ago, I feel like. But we have the review page here. Let's go check it out. And we've got review videos. I'm not just going to show the review video. We'll talk over the question. So might go through it a little bit quickly, but there are questions for each one of these going over how do you know what video you went over interpretations on. I think it was the 2 days ago video. Sorry, I haven't labeled these. Been answering emails and everything and haven't had time. But you'll see kind of some color coding. We were doing them earlier also. But we'll do interpretations more in here in a moment. But let's go check it out. So if you want, check out these right here. I also think I go through interpretations on the speed runs. So if you want to go through here, also the concept review goes through interpretations where you'll see t-test interpretations at the end, where at the very end of this, I will be interpreting my result and stating my conclusion. So with this right here, you can see the conclusion being stated. And so I do mention, I believe, the alpha when we fail to reject or do not reject the null. I should mention alpha there. So do mention your alpha level. Yeah, the test one question. We're going to do that next year. Great question. Mohammed, thank you so much for reminder. So let's go here and do the question one. So with this right here, here we go. This is a specific kind of t-test. It is a t-test. Why do we know it's a t-test? Let's start with our basic knowledge. Why do we know this is a t-test? Why do I know it's a t right now? Can anyone explain why this is a t-test? Because Mr. T is what? Why do I know instantaneously, okay, we're doing a t-test right here. That looks like t-test output to me. Because we're doing a what? We're testing the mean. So we should identify it's... Oh, does this... Probably the best way, points to Matthew right there, is to see the t-test right there. See, my brain goes, I don't go for the obvious. I go for the, like, theory. It is a t-test. And if we go to our... Matthew, great answer. Just go for what it says. The formula sheet will say t with n minus 1 degrees of freedom is equal to y bar minus mu naught s over square root of n. I should learn to read some alpha, right? What, and I'll make my handwriting a little bit clearer. We got the big pencil today, apparently. The first thing it wants me to figure out is the what, and this is a subscript right here. The first thing it wants me to figure out, just type the 2 letters in the chat because it's asking me what is this. So we would need to figure this out. It doesn't have it in the output. The degrees of freedom. How are you going to figure out the degrees of freedom? How are you going to figure out the degrees of freedom? Great job right there, Olivia and everybody. How are you going to figure out those degrees of freedom? The degrees of freedom are this. And so n minus 1. So the value up here is, this is n. And so what are the degrees of freedom? What are the degrees of freedom? 27. So we're just doing 28 minus 1. 27. 28 minus 1. Which is n minus 1. Which is noted right here as the degrees of freedom. It's a subscript telling you which t you are using. This is like a specific t. Great job, answers in the chat. Points. Hit random buttons. The next one is probably the hardest one. And that's a typo. It should not be double t right there. The next one is probably the toughest one for the test statistic. This is the test statistic. This will remove some of the highlighting. The test statistic is this. It's actually the whole thing, but we're not looking for the degrees of freedom for it. So we need to identify what is, well, we have the sample size up there. So we know what the sample size is. I'm going to highlight things and I want you to tell me what this is. That right there is the what? Maybe do, sure, thank you so much. This J's maybe do drugs. So the thing in blue is the standard deviation. So that's what that is. This value right here. Now you might have a harder time finding it. That value is what right there? That value is what? So I don't like the way Jump says it. I wish it just said what it is. Oh, great answer right there, Mohammed. You're all right. It is the sample mean. And the sample mean is our estimate. I hate that this is actual estimate, but it's it's what we saw in our sample. And then the naught just goes to this value being whatized. Like the naught over here explicitly would tell us it's what. Like when you see a naught, actually, yes, it's weird to say it's the actual estimate, right? The naught right there means it's a what value. Like you see p naught or mu naught or sigma naught. So the naught means it's what? Like, by adding a naught, it's not just the mean anymore. It's the hypothesized. So the naught part of it means the hypothesized. So now that we've got some color coding right here, it's going to become just a plug-in and solve the values problem. So with this now, and I'll write it out, solve it in the chat. So y bar is 18 point... And then S is going to be 2.46484 over square root of 28. And this is going to equal to, I'm blocking it. Is it like 1 point something? People solved it yesterday. 1 point, is it like 6.5? Who's got it? Try solving it on your own calculator. See if you get it. Good practice. What is it? What is your favorite color? Is it orange? No, blue. It's my favorite color. I think it's something like that. We'll see what people say. And this is going to be the T that we're solving for right here. Ooh, no one knows. Give it a second more. Good practice. Good practice. I'm going to let people solve it. I'll give it another 10 seconds. Pink! Blue! Pink! No! What is the speed of a laden swallow? Nope! I was wrong. Oh, it is negative, isn't it? Oh, wow.
Wow.
I was way off. Should have just looked and saw the difference up top was negative. I was trying to trick you. You did not fall for my tricks. You did not fall for the tricks. Trevor, it looks like you did not miscalculate. I miscalculated. You are now the master of statistics. I've lost. They're gonna... I'm gonna go teach Bio 1010 somewhere. So that is the value. Knowing the output's the key. That's probably the hardest one, the longest solve. Negative 2.944. Longest solve. And the easier one down here. I should have just looked at it. You can kind of tell where it's at. Oh, yeah, I should have guessed it's about 3. This value right here would be right here. Can anyone tell me how much this pink value is? How much is that pink value right there? Just identify for me. We're going to remove our other output. We had to solve to get this, and we're just drawing what jump would draw for us. How much is that shaded in area right there? We're talking about the third answer now. We're trying to solve for the third. We're just talking theoretically about this. How much is that area right there? I'll zoom in a little bit. So how much is that area right there? And here's a hint. How much is that area to the left of that? How much is that area to the left of that? So there's a hint right there. The area to the left of that value is what? I think Olivia, you're going to the next answer, or you're solving the final answer. Olivia, great answer right there. You're solving for the final answer. Muhammad is correct. That is the answer to the left of it. How much area is there to the right of it? Just follow the output right here. How much area is there to the right of it? How much area is there to the right of it? So just follow the output. So if you know that is 0.003, then to the right of it would be this. And then if we were to mirror image this onto the other side over here, how much area would there be if we mirror image it, which is going to be double? That's the answer. How much area would there be if we mirror image it to the other side? If you mirror image it to the other side and have the two together, it's going to be double. So the answer to the last question right here should be what of the smallest of the two? So does that make sense? Great job right there. It's going to be double the smallest. So the does not equals test is double the smallest. We did the less than, the greater than, and the does not equals, and kind of visualize what it would look like right here. So great stuff, great work. And thank you so much, everyone, for practicing. I want to say this, like, I keep saying this. I want people to know, like, what matters most in life. Go to the main screen. Big shout outs. Matthew, thank you so much. You give me so much positivity on the Discord. Matthew just talking great things about the Discord, talking about how we're going to improve it and all these different things. We always want people to have a good experience. The Discord occurred because I, during summer of 2020, said, I wish we had a Discord for my class. And 5 minutes later, a student named Dennis said, we now have a Discord. All it took was me putting that out there in the world and saying, I wish we had a Discord, and I said it at the right moment. A lot of life is moments. It's about 1 or 2 moments that if you say something or do something and help others, Dennis in that moment stepped up. And I'm forever thankful. And so many people have been, you're welcome. You're welcome. Of course, Lucy. It's about those moments. It's about going out for that interview with like Eastman or something like that. It's about saying, you know, I've got this opportunity. And maybe those opportunities don't work. I had said I wish we had a Discord multiple times. Yeah. Not that I'm referencing a movie, right? There's one or two moments in everybody's life where you can be amazing. Is this that moment? Don't. 2 times. So we have the less than and the greater than. What would the less than and the greater than? And I think we'll go back, Harper. We'll do a few more right here. So the less than and the greater than add up to what? If you have a less than test and a greater than test, it was not that moment. Less than or greater than test add up to what? The less than test and the greater than test will always add up to what? The less than test, the greater than test always add up to what? They add up to 1. So if you say less than is 0.2, greater than will be what? Like the less than test was 0.2, and the greater than test is thus what? Like the less than below is 20%, above would be what? Because the less than and greater than have to add up to this. It'd be 0.8. You can just be like, what adds up to 1? Or you could subtract from 1. But then we have the does not equals test. And the rule for the does not equals test is that the does not equals test, which is the two-tailed test, is always what the whatest. The does not equals test is always what the whatest. So we said we have a less than that's 0.2, a greater than that's 0.8. So the does not equals test, you can print it out or you can write it down, Vanessa, great question right there. 2 times the smallest. 2 times the smallest. So if the less than is 0.2, the greater than is 0.8, the does not equals would be what? It's 2 times the smallest, but what is that? The less than is 0.2, the greater than is 0.8, the does not equals is 2 times the smallest, so the does not equals would be, as Lauren says there, 0.4. Because you just reflect the tail on the other side. You've got 0.2 and you reflect it on the other side to get 20% total. Definitely check out the videos and we go over that a little bit more. Good questions and good practice. We have right here about, we're gonna do the chi-squared. And then I think we're gonna end with interpreting test results. There we go. Okay, let's do this. Gonna get some food here in a moment. Pokemon Walk food emails coming up later here on Stat 201. Let's go check this out. Okay, so how can we tell apart P hat versus P naught? Really great question right here. Yeah, of course. Yeah, thank you so much. Do you have the links to the Discord in these videos? Let me throw it out there right now. Thank you for asking that. Let me put the link to the Discord. There, we got a verification, so we should be all right if I make it public. Copy. This is Stat 201, Stat Nation. Invite people. If you haven't joined the Discord, join up. I offer extra credit for my classes. And then we have a verification bot. So we should be good on putting it out there. We try to make it as public as possible. Hence, we made a verification bot for to make sure it's running smoothly. We got a lot of great mods too, who really make sure that everything is good and people are positive. We've never had any issues, and we're trying to keep it that way. We want a very nice Discord. We love it, and we'll fix things as if anything arises because we don't want our own. So, how can we tell apart P hat and P naught when solving Z in a proportion hypothesis test? So, a really great question to ask right here is, why would we not have a P naught for intervals? Intervals would not have a P naught because you don't have hypothesized values, at least when calculating an interval. You could test a value with an interval, but the interval equation doesn't use P naught. How would we know in a written question if something is going to be a P hat? How would we know? I just want you to think theoretically. How would you know something is going to be a P hat? Now, there's no P naught with this, but how would you know and associate something with P hat? How would you know something is going to have a P hat, which is sample proportion? Yeah, exactly. Thank you, Hannah. Like, P hat is for a sample, so there'll always be, as Finch points out there, a sample size. So when we're doing the test right here, when we solve for a Z, which is not based on a level of confidence, we would have here P hat minus P naught over P naught Q naught over N square root. And the N right here, we would have to figure out the number of successes, but it's always going to be associated with the sample size. It's looking right now with the graded in the mid-low 70s. I'm predicting around a 73. I am 95% confident the true average grade on the test will be contained in the interval 68 to 78. So I'm estimating plus or minus 5 points around 73. I am 95% confident the true mean average of the test will be contained in the interval. I could actually run it. I could actually take the data and run it. I'd have to download the gradebook, and as tired as I am, I don't want to do that live on stream and downloading the gradebook, and I'm just not going to do that on stream. But I could create a confidence interval to estimate the true mean grade. The larger the sample, the better the interval would be. The more variation in test grades, the wider the interval is going to be based on standard deviation. But I can run the statistics on that. So with this equation right here, Finch, so right here we have the sample proportion, which is if you go out and talk to UT students, 20 of them. My brain is hardwired for statistics. Well, I could just go run. We'll know soon enough. If it was a longer thing, like a long running thing, I might actually run the stats on it, but create a confidence interval. But yeah, it'd be a confidence interval estimate the true mean test grade because it's quantitative. 50 people have taken it or so. It's a decent enough to get an estimate that the grades are not horrible. It's definitely not near a 40, which I hear Bio 1010, not at UT, has. Definitely not a 40 average. Anyways, so P hat right here, if we have 20 students who own a dog out of 50, what would P hat be? So 50 being the students who we've talked to, and 20 students own a dog, what would P hat be? What would P hat be? So if we have 20 students who own a dog out of 50, what would P hat be? So what you're hearing right now is you're hearing 20 students own a dog out of 50. That's what you're hearing. It'd be 0.4. 0.4 right there. Does that make sense? So P hat is the sample proportion. So, and this goes to the original question, how do we know something is a sample proportion? It must have associated with it a what? There must be some, whenever something is a sample proportion, it must have associated with it a what? You can put the letter in the chat or you can say it. Whenever something is a sample proportion, it must have associated with it a what? Anything that is a sample proportion must have associated with it a what? Anything that is a sample proportion must have associated with it a what? Anything that is a sample proportion must have associated with it a what? So if something is a sample proportion, it must have associated with it a what? Not 50, but the other. Again, I disappear if I reach into that realm. I've gone back in time and my parents have never met. That's the Brian that does not exist. Sample size, exactly. Anything that is a sample proportion must have associated with it a sample size because it's a sample proportion taken from a sample. So the key thing right here is to identify that there's a sample size, this is a sample proportion. Now, when it comes to hypothesized proportions can be what? What is possible right here with hypothesizing a proportion? Because it's just like you think it up. So you just say, so what is possible? Technically, there are bounds to this one between 0 and 1 because it is proportion. It's all Back to the Future all day long here, Lucy. What is possible when it comes to sample proportions? It's just whatever you hypothesize, right, Cherry? It's just like you just say, let me test this value. And that's what you would start with your null hypothesis being. You would say, I believe currently that the true proportion is equal to whatever I hypothesize it to be. And you just plug that value into what you hypothesize it to be. The valid alternatives, I think a lot of people know this, might be on the test for some people, are the less than, the greater than, and the does not equals. We don't use all of them at one time. There is no like less than, equal to, greater than, equal to. I can't, Alec. I'm sorry. They won't let me. I can't due to ethical. I'm a virtue ethicist. It would not be virtuous for me to take your test. Calculate the test from a hypothesized test. Sure. Let's do one of those real quick right here. Brian wants to see if a new diet works. He has he believes that the diet will have people lose more than 10 pounds. From his sample of 100 students, they lose, solve it in my head right here. They lose, I'm like solving this in my head and like backworking it. So, okay. They lose this 10 point, ooh, you'd be interested in this. Yes. 10.6 pounds with a standard deviation of 3. Then just solve for the test statistic. Yeah. All right. Shorter question. I'll explain how we solve this. I made the math easy on myself. I made the math very easy. Take a moment. Could you solve a question like this on the test? And I made the math easy on myself. Can you solve the answer? Who knows the answer? It's not too hard of a problem. There's a joke in there when you solve it, when I say it's not too hard of a problem. Someone's already like solving the riddle I put out there. I'm not trying to be like, it's not too hard of a problem. I'm just saying it's not too hard of a problem. With the mathematics, at least. If you know the formula, I'll put the formula down here in a second. Take a moment, try to solve the problem. Remember, it's not about me solving it. It's about your practice. The more you practice, the more you see the formulas and identify the equations, the better you do. So it's not too hard of a problem. I think someone's going to solve the riddle before. And you're like, is it this? Lucy, you're good at some riddles right there. All right, let's solve it. Let's solve it. Did anyone solve the actual problem? If you know what the standard error is, watch me be wrong and given a riddle that didn't work. Please identify the following notation. So please identify the following notation. There's the notation. Okay, so what do we have right here? This is a what? What are we doing? Identify the notation or tell me what we're doing. We're testing how much weight people lose. What kind of thing are we doing? I think... Yeah, Trevor, that's it. Yep. Trevor, great job, Trevor. Trevor got it, yep. And so, Trevor, what are you doing? Trevor's right. That is the equation. Trevor, great work. And I'll show what Trevor did. Trevor first identified we are doing a what right here. So, we are doing a what? So Trevor identified this. This is a what? Because we're testing how much weight people lose. We're testing how much weight people lose. So this is weight. So weight is quantitative. We are doing a what? We're doing a hypothesis test on the what? Great job, Olivia, right there. We're doing a hypothesis test on the what? We're hypothesis testing a mean because we're seeing how much weight do people lose, which is quantitative. Mr. T is mean, quantitative. So we're doing a T test, one sample T test. One sample because we don't have two groups right here. We're not saying like people on diet A versus people on diet B. It's just one group right here. We're testing the mean, which then on your formula sheet, you would see the following equation of y bar minus mu naught s over square root of n, which means we need to then identify here. Just made a 40. Let's go. Oh, that's all right. Don't worry. That's all right. That's all right. Look at that curve. And sorry to hear that. Who knows? There might be a curve. We don't know. We'll find out. We'll find out. And if people want to share their grade or whatever, their experiences, it's all right. Share your grade, share your experience. But remember, there are the interpretations. So there's a lot of different grades. And what I'm seeing right now, mentioned what we saw earlier. So what do we see right here? Has anyone taken the test and done well on it so far? I know there are some people, maybe someone in chat. Has anyone taken the test? Want to see what they have pre-curve? If you want, so I know some people have done well. I've seen it. One person could get 100. I didn't grade their interpretations, but there is an 84. There is at least one perfect on every thing. Because this one is doing a test statistic. So this one specifically says solve for the test statistic, like doing the test. And I'm writing a kind of quicker question. You can print it or write it down. You can print it or write it down. You can print it or write it down. So I might even like send it out on the Discord, like who has been feel free to share your experiences with the test. I know some people have been, I don't, everyone's grade is personal. You can share if you want, you can not share, but I know some people have been doing well. I think there's 47 questions. There's in the 40s. Laura, please, we can, if you file, sorry, if there's, please file with the Dean of Students or something, and we can make extensions. And so definitely let us know, and we can help with these things to create extensions. You can write down, Gear. I know a lot of great questions right now. So here, I'll identify the questions and we'll go on to some more. Let's keep working away. We got this. I know there's some great grades out there. I know it. I promise you, when I'm saying I'm seeing an average in the 60s before the interpretations, we are seeing that. And so let's go right here. Let's identify all the values. We see the 10 is the hypothesized. We see this. And then we're missing one more color right here. We observe this value right here. Whoops, wrong color right there. I think if someone asked that, and we're going to go for another 20 or 30 minutes right here. There's the values. So plugging in the values, we get 10.6 minus 10, and then 3 over square root of 100. And so I made the math easier on myself right here. We know afterwards, Harper, we know afterwards. So the instructors talk, we look over the exam, we see how the questions went, and then we talk afterwards. So we would only know this after the exam is given, and then we try to be as fair as possible, and we talk as instructors and discuss. So no, the instructors always look over. We always have like a debriefing after the exams. We want to give a fair and equal exam. Is y bar not 10.6 divided by 100 because it's not a proportion? This is quantitative. Correct, Hannah, right here. This is all quantitative. So we're doing the one sample T test. I believe so. I believe it was the Monday review. We went over interpretations, and we'll do some more here in a moment. So good questions right there. And let's see. We're going to do as many questions as we can. Will endings? Sure. And if you're wondering, do check this out. We do have the review videos. I just want to point these out again because I'm probably going to end like 20 minutes. Because I need to make sure everything's going smoothly by looking at emails and stuff, which I don't do on Instagram, obviously. But do check out the review page if you haven't. And I want to point to Mubot. Where you at, man? Here's the review page. Thank you so much, Lucy, right there. That's really what we try to be. We try to look over everything, make sure everything was tested fairly. We look over the questions. We actually have an analysis to see how the questions are doing. I get Y bar and mu mixed up a lot when looking at the mean. Yeah, and then it's the hypothesized. So if you're wondering about the conditions, and we talked about them a little bit earlier, I might just put this out there. Gotta always say right? So if you want to go over the conditions, check out the page Mubot just put in the chat, and we talk about the expected cell counts and the count data, and I explain these right here. If you want a more in-depth on the chi-squared with the conditions, check out the chi-squared video where I go through a full example of the chi-squared right here. What are the two slides we're allowed to use on the... Oh, there's not... if you're talking 201, there's not two slides. There's just the formula sheet. And so right here, we go through the conditions. So we should have conditions right here and expected cell counts going through and talking about what the conditions are and calculating all the values by hand and talking about the degrees of freedom and all this stuff right here. So this is a full chi-squared by hand right here, explaining to you how to do the chi-squared test of independence and walking through each step of the test, finally going to the conclusion. For the formula sheet, it is on the review page that Mubot posted in the chat, and check out the formula sheet right here, which you can print off or write down. Just make sure to show it at the start of the exam. Just say, here's my formula sheet, and don't have like on a notebook or something like that. Panel said there's two slides. I don't know about that, and I'll have to learn about that. I don't know what that is. That confuses me. I'd have to find out about that. For the chi-squared, the degrees of freedom are rows minus 1 times, or the expected cell count is rows, row total times column total over grand total. That is correct for the expected right here. I don't know actually either. So I'm like, double check on all that info because I haven't heard any word of that. And I'll try to check through my communications too. What is the link for the formula sheet? Formula sheet right here for you. Thank you for asking, Gear, right there. Formula sheet in the link. Yeah, I don't know about this either. I would think it's just formula sheet. Like, I don't know. Yeah, I'll find out about it later. I'll see what's going on. We'll figure out what's going on with the world. Let's hop back into the main screen. Awesome. I will communicate. We'll find out. And let's do a few more questions. Reading chi-squared output. And then we'll do some interpretation. Question 3 on the practice exam. The p-value must be low. So the p-value, and do this, definitely check us out. I'm going to go to a quick version of this. We're going to do a quick version. So question 3, number 5 on the practice exam. Let's do a quickie right here and find it out. Thank you, Troop T. This music, I think it's helped. Like, it helps me, like, chill. Like, I really appreciate everyone being here. Like, imagine if I did a stream and no one showed up, and then I'm just like... So, where is question 5? Brian, do you not have question 5 on here? We should have question 5. Am I going mad? Here it is. It says type 1 errors. Did we renumber the exam? So question 5, let me go look at it. And could you ever, why I reject the null for question 3, number 5. Question 3, number 5. Question 3. Brain, turn on. Start working. Question 4. There's question 3. Label your videos, Brian. Okay. United States. Okay. So the very end of this is going to do... I see it. So with this right here, at the very end of this, it's going to ask, are we going to reject the null or not reject the null at the 0.01 level of significance? So when we look at this output right here, and we are testing what here? I think I write out the null and the alternative. So the alternative is that the difference between people have a job. Great luck on the job interview. You got this, Ashley. Job interview more important than statistics. I'm just putting that out there. Great job, Ashley. Everyone give Ashley 100 points. Ashley right there. Give Ashley some positive vibes right here with it coming up. So the alternative right here is the greater than. Now, what am I going to look at? 1, 2, or 3 right here. With the alternative, are we going to look at 1, 2, or 3? And the alternative is written out for us. Are we going to look at 1, 2, or 3? Which of these will we look at here with the alternative? Thank you so much, everyone, with that positivity right there. We're going to look at 1, 2. So awesome, Ashley. We're going to look at number 2. Why are we looking at number 2? The sign of the alternative, which we're testing to see if the USA has a greater value than the Britain value, the mean, because of the sign of the alternative. Just match up right here, greater than, and you would have to have this written out to know that we are doing the greater than test. So the question in and of itself is going to ask, are we looking to see if there's a greater than difference? So write down the null and alternative suggesting by the first step in the sentence, which is researchers believe that British men are shorter. So you might say, well, wouldn't it be less than? But remember, we're doing USA minus Britain. So if the difference is positive, that would mean USA men are water. Thank you, Ashley, right there. So optional but recommended. Proctoral have an online calculator. Sketchy. Printed copy of the exam. I don't know the 2 power. I don't know what that is. I'll find out. I'll ask around. Is that USA men would be taller? USA men would be taller. So with USA men being taller, like this is the alternative right here, that means British men are shorter. So British men would be shorter, which this is the proper than alternative. So then the question becomes, why do we reject the null? We always reject the null when the p-value is what? Now, you might be thinking a certain value, but I just want you to give the general term for the value. We always reject the null when the p-value is what? We always reject the null when the p-value is what? Now, lower than alpha, great job right there. Low and then lower than alpha. Reject the null when the p-value is low, lower than alpha. So it's telling us that alpha is 0.01. Since alpha is 0.01, we have to go and look at the p-value here. And the p-value we see, did I circle the right p-value? I think I did. The p-value we see, we're not going to use both those. I'm just explaining what those p-values are in the video. The p-value we see is 0.0054. So the value of right here, if we were interpreting this, I reject the null that there is no difference. This goes to interpretation. I reject the null that there is no difference between the mean of USA heights and minus the mean of British heights. I have evidence, or I could say at the 0.05, at the 0.01 level of significance, I reject the null with a p-value of 0.0054. And the null has to go, Julie, for a nice job, Julie. Oh, Julie's great. I got to contact her about department stuff. So many things. I'm going to repeat my interpretation. My p-value of 0.0054 is lower than alpha of 0.01. Thus, I reject the null hypothesis and have evidence that the mean for USA heights is greater than the mean, the true mean for USA heights is greater than the mean for British men height. It is less than 0.01. Hence, we reject the null. Does that make sense? And great answers right there, everybody. Great job. Excellent, excellent work. You know what, Lucy, something crazy happened. I think I can show this. Has anyone watched the really crazy long review we did? I've just had so much craziness happen with random things. We don't like randomness. We don't like bad randomness. But I think I can show this in my creator studio. But if you saw, I think I can show this right here. I don't like anything. We got a copyright claim on the video where somebody copyright claimed the 8-hour video. Yeah. They copyright claimed it, claiming, and it's over my voice. It's over when I'm announcing the everything. So they copyright claimed the 8-hour video. It goes through a 30-day dispute. There's a guy like, something Mike or something who reviews Dragon Ball videos, and he's talking about how it deals with him. But, yeah, so I put in the dispute, but it might have ads on it. I don't put ads on videos unless they're like general purpose videos. but I wouldn't do that. Sue YouTube. So yeah, I don't. But yeah, so if there's ads on that video, I'm very sorry. But they copyright claimed it on me because they probably just saw an 8-hour stream that people were watching. Like, hey, I'm going to copyright claim this. There should be a calculator on the exam. I would definitely bring your own, but it should be enabled. I'd have your own calculator. Have your own calculator out. So bring a calculator. So it's not strikes. It's just copyright claims, which doesn't. I can get in trouble if I dispute something, and they'll strike my channel or they could even terminate my channel if I. So it's a little scary when you go to a dispute. Is like, is my voice copyright claimable? You're posting the slide on Discord. Let me take a look at this. This is the slide allowed? Yeah, I'm wondering why this slide. I'm gonna send a message. Let me send a message. Just I'm gonna ask questions. Step 2.1 flowchart. Students informing. All right. Okay. I probably have to go to Moa because I'm going to answer more emails. Yeah, definitely. Yeah. Yeah, this is all news to me. Exam day stuff. Woo! It's exam day. Who else is hype right here? We do allude to many fictional properties on this channel. Thank you, Demetrius. Thank you, Demetrius. If you've taken the exam so far, any time, but we do. I'd probably say, Gear, that might be the latest, but I would not suggest starting super duper 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 late. I'm gonna put on one of my favorite songs right now, and then we're gonna do a little bit more. Hype to your last exam, Sharia. Sharia. If I'm mispronouncing anyone's name, please tell me. I'm very sorry about that. But congrats to you. You got this. Keep it up. Excellent work. You got this. Last exam, Shreya, you got this. Awesome stuff right there. Step forward, start with the truth by finding. Oh, hey! Thank you so much. Okay, good. Thank you so much. Okay, I like that. Awesome. Thank you. Thank you for telling me. Thank you so much. Last exam. Yeah, I don't know of You got this. You got this. It's number one thing. We keep saying this. We're gonna do a little more after this. Number one thing is to practice your whats. As far So I put a message in the Discord right there about this, but I'll update on information. Like it's news to me. Like yeah. And so they don't have a cheat sheet though, Lucy, but that's for 324, 74, 475. No, but Lucy's right. In our I thought the music was going down. That's for 320. Yeah, great stuff right there. Don't have a cheat for this exam. That's in our upper level classes. We do allow for cheat sheets in those classes. And I think we'll do some test of independence. Has anyone, let's throw a little more positivity out here. You can put it in the chat if you want, and I'm probably going to go for, I'm putting a time limit on myself. I'm going to go for 20 more, for 2 hours, 23 minutes. Test interpretation, you bet we'll do some of that. Has anyone taken the test so far for 201 and done well? Because I know there are some. I don't know if you're watching right now. Mubot says we have 56 people watching. I can't see any of the chat history in Discord. Contact me, I'll try to get it fixed up. Formula sheet really helps out. We're going to try to, we'll figure out what's going on. Is the general chat talking? Yeah. Word is going around about how hard the exam is. Let's start doing another question here in a second. Let's do some chi-squared. Let's hop over here to some chi-squared. We got this, everyone. Yeah. Well, tell them, hop on, say, jump on the Discord, and if they want to talk about it, there are people doing well in this. I just want you to know that. It is a tough exam. It's not the easiest exam. There can be small questions from the business analytics. Small questions. So if you showed up to business analytics, you know about like Target, and you know about Moneyball, if you know about girl getting pregnant and Target finding out, then you'll do fine on those. So we got this, everyone. If someone wants to hop on here and say, hey, I made this before the interpretations, I'd love that, because I promise you, I'm thinking it's going to be a low C average on the exam. That's my, and I know low C is not great. People don't want to make a low C, but at least that means we'll see variation around it. So it's a tougher exam, though. Let's hop over here and do some more interpretation. Okay, so a chi-squared. Let's up our access a little bit here. Probably one of my favorite things is when we give you the chi-squared and we ask you to solve for values. So we've got here a chi-squared test of independence, and how do we know? We'll see. Wilson, good to see you, Wilson. Exactly, Hannah's right there. C's with some B's get degrees, exactly. So when we look at this table right here, and we'll grab it over here. So what do we got going on right here? What do we got going on? We have right here 2 values that are missing. Really great question on the practice test. And so what test are we doing? Like, you should see this, say that's a contingency table, instantaneously know what test you're doing. Contingency tables have 2 categorical variables. And with 2 categorical variables, we're doing the chi-squared test of independence because it's 2 categoricals. The null hypothesis right here would be that somebody's age group is independent. You literally put the word independent between right here. So you'd say somebody's age group is independent of their political party. Like, it doesn't matter. Rock knows what's up. So somebody's age group would be independent of their political party. Knowing someone's age group would tell you nothing about their political party. Now, when we're solving values right here, you want to look at the following grid and see that the missing value right here in A is a what value. Look to the following grid to see that this is a what value. So the missing value in A is a what value. That is a what value. And definitely, until grades are finalized, don't worry. I'll be handling all. Expected. So that's the expected because it's in the second position. On our formula sheet, we will see the following formula. Row total, that stands for row total, times column total over grand total. I just want to say, huge shout out to Lucy. So much positivity. I love it. Equals the expected count. So the best way to do this is to go right here, take your row total, take your column total, and divide by the grand total when you multiply those two together. Row total times column total over grand total, and that is going to get you the following formula. Great job right there, Trevor, finding the expected count and has written the formula in the chat right there. So what does that equal to? And there's a way to check this also. What value are you getting, Trevor, when you solve that in the chat right there? Thank you so much. Lucy, just always swing back by and keep me updated. Just so excited and so proud of our students. So, been crazy year and a half. Things get calm for a little bit and then everything catches fire. Everything's fine. And so the value right here in A is going to be 162.79, but there is a check. This is advanced. There is a check you can do by taking all the expecteds and adding them up. So there's actually an alternative solve for it, that you would take these expecteds right here and add them up. I think that's... As long as I did it right. And we get some decimal change that's missing on the end, but all the expecteds would add up to the total. So that is row total times column total over grand total on how to get that value. Now, the other value we see missing in B is a cell what? It is a cell chi-squared. So the cell chi-squared is missing here. And the cell chi-squared, great job right there, Catherine, everybody practicing, is the observed minus the expected squared over expected. And that is equal to a cell chi-squared. So with this being the cell chi-squared, the observed is the what now? So take a moment, try to solve this. Be like, okay, I got to solve. Yeah, we call it expected count. Expected cell counts. That they have to be greater than 5, which we would pass that. Great question right there. All the expecteds are greater than or equal to 5. They do pass that. And so this right here is going to be the observed minus the expected squared over the expected. I'll write in the numbers right here and then try to solve, see if you get the same answer. So observed is 162. That is the count we see in the cell that we're looking at. I'll go back to just highlighting that one. And then 144.754. 144.7. Got there? And so the cell chi-squared is a what? The cell chi-squared is a what? The cell chi-squared is going to be, so just solve it right here. What do we got? Like a difference of 18 squared. It's going to be smaller, right? It's going to be like 1 point something, 2.5, 2.05, 2.05. Nice job. Great work right there. It looks to be about 2.05. I was estimating like high 1. Has to be a positive number, 2.05. Double check your calculator. Make sure we should be getting 2.05. I'm going to solve it. 2.05 sounds right to me. We take the observed minus the expected, square that. It's going to be the 2 answer. And there we go right there. So that is the cell chi-squared. Now, what do we do with cell chi-squareds to get the chi-squared test statistic? The chi-squared test statistic down here would be found by what following methodology? The Pearson chi-squared test statistics. There are multiple choice the interpretations we have. We'll probably do one interpretation down here in a moment. We add them up. We sum up the cell chi-squareds to get the Pearson chi-squared test statistic. And now it's very, very clear. What are we going to do on this test? On this test right here, because the p-value is low, which goes to an interpretation, briefly explain your answer. Well, my p-value is 0.0001, which is less than 0.05. Thus, I what the null. My p-value of 0.00001 is less than 0.005. Thus, I reject the null hypothesis and have evidence. You can say in favor of the alternative. I have evidence for the alternative. And what does that mean? That means we have evidence that we have evidence that somebody's what? So my p-value of 0.00001 is less than 0.005. Thus, I reject the null hypothesis. I have evidence for the alternative that somebody's what is what of their what. I have evidence that somebody's age group is associated or not independent of their political party. And so does that make sense? Kind of a quick overview of the chi-squared right here. Quick overview of the chi-squared. And their age group is, the alternative is that it's not independent though, Sam. Good work right there. And not independent means associated with. The null is that they're independent. The alternative can be stated that they're associated, i.e. not independent. Does that make sense, Sam? The null is that they're independent. The alternative is that they're not independent. It's probably the easiest way to be like, the null is that they're independent. The alternative is that they're not independent. I have sufficient evidence to conclude that at the, Hannah, I think, gives a top tier answer. The 0.5 level, and maybe take the p-value, Hannah. Hannah, I threw out 100 points. This looks great. I have significant evidence to conclude at the 0.005 level with a p-value of 0.001. I'd maybe just take the p-value. That someone's age is not independent of the political party. Hannah, that sounds great. I would just throw the p-value on and you've got an A+ answer. Great job, Hannah, right there. I have sufficient evidence to conclude at the 0.005 level with a p-value of 0.001. And you're saying my p-value is lower than that. Like, I understand that is great statistical analysis right there. I just mentioned the p-value and you'd be great right there. And then you've stated your alternative. If the grader took off points, even with that right there, the way it is, I'd probably be like, the grader shouldn't take off points. If you can always look at your test and tell me if you disagree. I might agree with the graders, I might disagree. You never know. Generally, it doesn't matter, Ashley. Generally, it's just like, does X explain Y? So usually we try to put X by Y. Does someone's age group explain what political party they're in? So we probably would want this to be the X. Like, your age would explain your political party. So are you independent? Exactly. We have evidence of an association. Great job, Lucy, right there. Knows classic, because we can't say it proves or causes somebody to be this, but there's an association. And then sometimes we prefer to have one of them be the X, but if X is associated with Y, Y is associated with X. So you can flip them in the mathematics. The computer, it doesn't care about which way you do it. Let's end off here. I think we've gone through pretty much all the questions people have asked. And thank you so much, everybody. Really great stream. Just did a little pop-up stream right here. And we've been going through all the questions. We did the chi-square. Let's do some test interpretations. So let's do this. Test interpretations. Where did we put the test interpretation? Okay. Let's hop over to the main screen and just talk about what you need to mention, which people were doing a great job of it just a second ago. So what is a big thing to mention when doing your test interpretation? Here we're testing the GPAs of people in the honors program and not in the honors program. So probably a very big thing to mention when you're doing an interpretation of a test result is to mention to start out first what? Like, you want to say this and then give this. So here are how we write our conclusions when doing nulls and alternatives. Then we kind of have a route. I should almost do 2A and 2B as I look this over. So when we start off, we are going to start by stating our p-value. And the big thing is if are we rejecting or not rejecting, right? That's kind of the key right here. Are we and so this won't have levels of confidence. The confidence intervals will. On a test, the big thing is my p-value of this at or below alpha, or is it above alpha? So the big thing when doing a test will be the p-value for the test. Does that make sense? And we're going to compare it to alpha. So when you're doing a test, you really want to go straight to the p-value you're doing. We're doing a does not equals test here apparently, because I've highlighted this one. And then we say, is our p-value below alpha or is it above alpha? At or above alpha technically. If it is at or at, oh my gosh, at or is it below alpha or not below? Is it below alpha or not? There you go. Compliments. Nice and easy way of phrasing it. Because I'm trying to say, is it at or above alpha or below alpha? So it's either below alpha or it's not. Below alpha means less than whatever alpha is, usually 0.05. Alpha is just a bar we go to. Yep, they will give alpha. 100%. If I give you an alpha here of, just start off with this. If I say alpha is equal to this, what do you decide? If it below... Points in the chat right there. If it is... It's all those bright lights. The real bright lights over there. If it is below alpha or not. So if alpha is this, because this value is below, there's the p-value, so we are going to reject the null. The p-value is below alpha. So we'd start out by saying here, my p-value of 0.00001 is less than the alpha of 0.10. There's no level of confidence mentioned here. I've looked over a few things. There's no level of confidence because this is for testing. Tests and confidence intervals are interrelated, but we don't mention a confidence level. By null, you're about to go. You got it right there, Ashley. Great job, Ashley. So we're going to reject the null. So if it is below alpha, talk about rejecting the null and the evidence we have for the alternative. So the alternative we're using right here is that there is a difference between the mean GPA of individuals in the honors program and not in the honors program, that the difference is not equal to 0. We'll do one more. Gonna be final problem of the day. So see if you could get this. If we go over here and we test to see, I'm gonna do a tricky one, maybe. Let's see if we can get this. Okay, let's test evaluate here. If you look closely at the screen, that'll give you a hint for what we're doing. Get on TikTok? What's on TikTok? Oh my gosh, are we on it? So what have we done? What is on TikTok and what's going on? You have to drop a link now. I'm gonna like watch it. I'm scared. I'm like, this is gonna be awesome. It sounds awesome, right? Haha. If you said like oh, well, thank you. That's so nice. Thank you everybody. I mean, like, it's just I like that hankering about. Thank you so much. I appreciate if you want to send me some of those. It's been a crazy bio 1010. I appreciate that. That's really, really nice. We got a lot of great people here at UT. Like, I've got so many. I was meeting with Dr. Eric Kelly yesterday, Dr. Mark Collins, Terry Higgins, Dr. Panel, Janie Williams. We got so many people who really care about students. Well, thank you so much. And I don't teach bio 1010. I don't know if anyone's figured that out yet. I don't get it. Let me see. Has that fixed itself? Nope. Okay. Okay, here we go. I'm gonna focus. All right, and then I am gonna go soon because I'm gonna answer emails and see everything's happening and make sure everything's not on fire. We need to get back working on my thesis paper. Yeah, thanks for so much. Yeah, thank you so much, Lucy. Thank you so much, Lucy. Yeah. Apparently, right, Finch? Apparently, I teach bio 1010. Finch figured it out. Apparently, I'm a bio 1010 teacher. There's another Brian Stevens. Don't do whatever you do. Don't. He's doing his own thing, and someone went to review a class that wasn't my class, and I can take a bad review, but I don't teach bio 1010. Anyways, what? Merry Christmas. Okay. And thank you for all the positivity. It really means a lot to me because I just want students to be happy and I want students to enjoy class and learn. What do we got right here? What tests have we done? What have we hypothesized? And what is our conclusion? Okay, so what is the result right here? I've never heard of that site before. What are our conclusions on this test? Now, this result right... well, thank you. I don't know. We'll see what they... I don't know. Why does it exist? So what are our conclusions? We are testing to see if the proportion, I'm just writing out kind of a question, of students who have student loans is equal to or not equal to 50%. Okay. I can take, there's some people who don't like the class. I saw the 1 out of 5 and I was like, oof. And I was like, I did give out a lot of extra credit. And I saw bio 1010. I was like, that's not me. And then I researched and I was like, oh, that's another person with my name, but spelled differently. So what do we have right here? People can give me negative reviews. I don't like that, but I don't want a review that doesn't belong to me there. It's not me. Thank you so much, Ashley. If someone doesn't like the class, that's okay. That happens. It's just like, why? I'm the one who put in the critique. I also put in a response from the professor because I do have an account. Like, I replied to it and I think they removed my reply. I'm like, okay, so you removed my reply saying, I'm sorry you didn't like your class. This seems to be for another Brian Stevens at another university. And I know which one it is because I went and looked up all you gotta do is search the name and search the class. And it's pretty easy to tell that there is someone who teaches that class at another university with a very similar name to me. Just spell the Y. So this is not the one. I'm gonna wait, you ready? Get back on track right here. This is not the one sample T though, and why? So Trevor, good answer right here. Trevor, you got this. It's not a one sample T and why, Trevor? So why is it not a one sample T? We're getting our brains back on track here. Why is it not a one sample T? Why is it not a one sample T? It's not a one sample T because Mr. T is mean. It's categorical. And so the key word right here is going to be proportion. And that's going to kind of clue us in that we are dealing with... I agree, Finch. So that right there is cluing us in that it's categorical. And so, yeah, there you go. Just like double check. There's little like... And so now when you do this, we're testing to see if the true proportion of people who have student loans is 50%. So the number one thing, and it is doing with a chi-square, we usually do this one with a z. So, but just look at the p-value right here. We usually do it with a z. I know it's confusing. Maybe I shouldn't have done this one because there's another way to do it mathematically. But just pretend, just use your, will it work? Use your imagination. And just imagine for a moment that says z right there. Just use your imagination. And so that says z now. So this is analogous to the z-test. So what is your conclusion right here? And I maybe should give you an alpha level, but using any alpha level, use an alpha of 0.05, classic alpha. So there is the z-test. It's just that jump uses it's just different mathematics. It's arriving to the same conclusion we would arrive to. Like I can work this all out, come to the conclusion with a p-value, but very specifically that p-value would be what? So we are testing to see if the proportion of students who have student loans is equal to or not equal to 50%. Use an alpha of 0.05 to state your conclusion. And the p-value here is going to be very important. We would fail to reject the null. Keep going. You got this, Hannah. Correct. This fails to reject the null. Well, we don't always fail to reject. I can do one here where we do reject. And so the p-value, don't worry, that's the chi-squared. I'm going to delete that output from here. How will you know something is a p-value? P-values will always have a prob on it. So, that's great. Mackenzie, if you want to send me a picture of that, do. I like to add resources. If you want to send that, I try to grow resources, and then sometimes I forget what I have. But, so we do fail to reject the null. And I'll do one where we reject the null in a moment. Because the p-value of 0.7247 is higher than 0.05. Continue on. And I'll start writing this. Great stuff right here. So because our p-value of 0.07247 is greater than 0.05, I fail to reject the null. That what? I fail to reject the null that what? Be careful. Remember, the null has the something sign. And so, so what is the null then? I fail to reject the null. It's about as full of an answer as we could get. There we go, right there. The proportion. So we're trying to understand the proportion of students who have loans. So because our p-value, like we're saying, in other words, it's believable that, and this is real data, it's believable that around 50% of students have student loans. Exactly. We fail to reject the null that 50%, the true proportion of students who have student loans is 50%. I do not evidence for the alternative that it is not. I'm saying the true proportion of students who have student loans. I've just abbreviated. So that's way right there. And so we'll do one where we reject the null now. This will be the last question because I am going to make sure everything's not on fire with the world because sometimes the world's just burning down. So let's do think about what I'm going to be doing right here. This is quantitative, and let me look. And let's do a does not equals test right here. And when I click test mean, that's a good hint we're doing a test on the mean. Oh, really? That's so far. I don't want to make it that obvious. Let me test. We did pet expense yesterday. How much people work? That's interesting. Very right skew distribution. Okay, so we're testing how much people work, which is quantitative, hence the mean. And let's go ahead and test a value. And you might notice a value I'm picking is purposely outside the interval. So be very careful. I'm asking a tricky question. Kayla, thank you so much. And Kayla, if you want to, anyone wants to talk, I'd love it. I love people spreading that positivity right here. Thank you so much, Kayla, right there. We're here to spread some positivity. It's a tough test, but I promise you, these reviews have a lot of things that are on the test. Oh, no. I'm sorry, Finch. My fiance is like, just don't burn food, Brian, because I'll leave something in the burner or something, and she'll be like, now the whole apartment smells of burnt food. Okay. My fiance would agree with you. She would say Brian burns food. Be very careful right here. I'm going to throw a trick into this. I'm throwing a trick. You might already... so let's test the alternative that the true mean is equal to 8.8 hours a week a student works. So we're testing how often, how often. Chat is killing me. Chat is killing me. Okay. In statistical notation, we've written out the test. Hopefully people can read my handwriting up here. I've stated that alpha is 0.02. And oh, that sounds amazing. I swear I just might make brownies and eat them all tonight just to say congrats for the end of the semester. I have thrown a trick into this question. We are testing how many hours a week students work. We are testing how many hours a week students work. How do we know when to use decimals or when to use percentages? Proportions can use percentages. Means used won't be turned to percentages to Ashley's question. So what would be our conclusion on this test? So what is the first step right here? What we have to do. So take a look right here. What is our first step we have to do? The very first step. The very first step right here is what? The very first step is going to be what? Oh, chat, you're killing me. State the p-value, exactly. And then compare it to what? I threw a trick in here, Mohammed. I threw a trick. State the p-value and compare it to what? There is a trick on this one. State the p-value and compare it to what? So we need to then choose the associated alpha level. And so the p-value here is this one because of the does not equals test. The does not equals is the two-tailed test right there. So your p-value, you can start by writing it right here. Just practice writing it. It's going to be on the test and stuff. Your p-value is 0.0216. And your alpha level is 0.02. I'm going to change the question here in a moment so we can change what's going on. I'm just trying to do some tricky ways of asking these things. So what is... Muhammad sees it. Great job, Muhammad. I'm going to throw out 100 points. Muhammad, keep it up. You got this. You're seeing it. And that's where you're like, oh, it's this. Oh, be careful, careful. I threw a trick on this one, Ashley. So start by stating it. My p-value is this. My alpha is this. We fail to reject. And why do we fail to reject? My p-value, I'll start writing it. So my p-value of 0.0216 is greater than my value of alpha, which is 0.02. The problem would specify this. I fail to reject the null that the true mean hours of work for students is equal to 8.8 hours. I do not have evidence of a difference from 8.8 hours on that. Does this make sense right here? And so I think we got some great answers in the chat, but my p-value is greater than alpha. I do not reject the null. They would tell you the alpha. And I can change this problem very quickly by changing the alpha here to the classic, which you probably were thinking originally we were going to use, so I did a little trick, to the classic of 0.05. So now we need to rewind time here. And what's going to happen now on this problem? Now what's going to happen on this problem right here? We'll zoom back in a little bit so you can see a little bit better. I am blind. So what's going to happen? There are interpretation problems, Macy. So there are interpretation problems. Hence why we're doing this right here. I wonder if I could bring Jolly over here. Just like if something bad happens, then I would feel so bad. I bet I could pick up Jolly. Might end the semester. Maybe I'll end with Jolly. Jolly has one eye. He's an adopted bunny with one eye. So he had to have a surgery when he was very young, but he's so nice. Watch him like get frantic when I don't know. I'll bring him over here. I'm like debating it. Exactly. My p-value of 0.0216 is below alpha of 0.05. I reject the null hypothesis and have evidence for the alternative that the true mean hours of work is different than, or is not equal to, is different, not equal to the same thing, is not equal to 8.8 hours. Yeah. think I'll be right with it. It's like spelled Jolly from like the not Emperor's New Groove, from Hunchback. He's like a mountain goat. And so wait, let's see if I can do this. Let me see. I'll probably end the stream quickly after that because I want to put him back up, make sure he's all right. Let's see if he wants me to. I'll see if he lets me carry him. So one moment right here. I'll introduce Jolly. I have a friend from middle school who had a rabbit and they had to. Oh yeah, I'm sure dogs can be all right with one leg too. We like one class got 2 points, one class got 1 point. So we had like 81 and 76. Good job. So let's see. Be right back. I'm gonna end the stream and because I'm gonna go put him up and then I'll go to the outro screen here. Let's see if he wants to be picked up, or like I might come back and be like, nah, he's not having it. I'll see if he's okay with it, and if he is, he'll make his appearance, and I'll probably bring him back out because if he got out in this room, if he like jumped out of my hands, he'll be all right. Okay, let's try. I'm gonna do it real quick. Jolly, you good? You good, Jolly? Doesn't really think. You good? You see all the wires. You want to say hey to people? I'm gonna pick you up just slightly. Gotta support you. Good, Jolly. Say hey to the people. Go, Jolly. Okay, we're gonna go away, Jolly, now. You ready? Gonna pick you up again. Good, Jolly. Good boy. Good, Jolly. Did you treat? Good, Jolly. Where's Jolly? There we go. I got in here and I had to have both hands, so I had to put him in my lap for him to, like when you pick up a bunny, you want to support them, like they're really long, so you hold like a hand over their chest and you keep their legs free because they have to, you don't want the bunny to kick, because, well, bunnies are not a huge fan of being picked up, but I'd pick him up, he has a bigger area we put him in to like, he can go around a little bit, but he, like when I brought him in here, I had to press the button to unmute myself. And so I had to free a hand. So I had to put him in my lap, but so I'm going to pick him back up. He doesn't love being picked up, but you know, you have to pick him up to move around sometimes. But Morty doesn't want to get picked up. Morty, no. If you say bring Morty in here, Morty, we pick up Morty very sparingly. He's bigger and he really doesn't like being picked up. Jolly is more used to it. Naming him Chi Square and watching my friends. Let me get my buddies going. Told me they ran away. Oh no! Oh, I'm so sorry. I'm so sorry. Yeah, that's Jolly right there. He's really cute. He's like our mountain goat. He's named Jolly because it's just a fun name. And then he's very jolly. He's very happy. And like the Hunchback of Notre Dame, he's like a mountain goat where he climbs on you. His full name is Jolly Jan Michael Vincent, because there has to be some Rick and Morty reference to his name. I mean, I'm the one who kind of like, it's got to be a Rick and Morty, because that's where Morty is named Morty. Or like, I was like, Morty, you little. Morty's the troublemaker. He hopped into Jolly's enclosure last week. He's so cute. Aww. Yeah, Morty, I was giving Jolly, I put Jolly up and was giving him food, and Morty literally went over a thing about 1.5 2 foot high. They're still bonding. They're better when than they first met. We tried to do some bonding. We're trying to get them there. Oh, thank you, Trevor. Thank you, Trevor. Thank you so much, everyone, for that positivity. If there's been a TikTok video or something, send me those TikTok links. I'm gonna probably get some food, relax here for a moment, and see if the world's on fire. You got this, Sam. Sam, send the positivity when you take it. If you want to drop, if you do well, mention in the GroupMe. I know people are like, oh man, this is a tough test. It's not a 40 average, but you got it, Troop T. Thank you so much. Let me go back to the main screen. I would love it if we, Jolly's just a lot of, Chelsea's away right now, and so, you're welcome, Shreya. Great job. 320, yes! I'm just gonna go all in and make you a mod. Thank you so much, and I look forward to 320. I'll be sending announcements and sending out things to help out. You're welcome, Olivia. Oh, there's a TikTok right here. What are people saying? What are people doing?
Are you a Nicki fan?
Oh, yeah, that's awesome. That's awesome. That's awesome. Thank you at all to Tiny Brian and his parrot. You know what that means. You know what that means it's time for. Give me a second. This, let me go out. Let me do this. We're ending with something fun. Give me a second. Give me a second. This goes out to all the students here to end class. We're going to end on something crazy right here. Give me a second, Ashley. I'm going to set this up, so it's going to take 1.5 minutes, I think. Stay tuned for something crazy. If you see another version of me on the screen, just ignore him right now. No, I can't edit that, can I? Can I not edit? Oh, wait. Oh, wait, I can. Here it is. I found it. Found it. 2 seconds, everybody. We're making this happen. This is happening. You're gonna find out. Okay, don't worry, I will be back. Okay. This is happening, everyone.
There we go. Okay, it's my show now. Okay, wait. No. Now we're going to our real music. Here we go. It's time, everybody. End of the semester. Tiny Brian was really behind the show the whole time. I'm your stats teacher, not that Brian guy. It's really Tiny Brian. I got over my laryngitis. Let's go over here to the main screen and see where Tiny Brian really lives. Burb, what are you doing? I'm hanging out over here with my crew, my tiny crew on my tiny pirate ship, with my big Burb right there. Tiny Brian, you Burb. Woo! Burb, you're a good Burb. Yeah! Tiny Brian here on Tiny Brian's pirate ship. Tiny Brian out! Bye, everybody! Bye for now! I'm the real host of the show. I'm Ant-Man. Tiny Brian away. I'm on a boat. Anything is possible!
Thank you, everybody. Great job, Carson. Everyone, great to see you. Mackenzie, stay positive, stay strong. We're out. Bye, everybody.
It's my show. Go away, Brian.